Technology and Research at Marden. We have Ana Cabral Gardner, who's the co-CEO of Sigma Lithium Corporation. We have Brian Anderson, Dr. Brian Anderson, who's Director of the National Energy Technology Laboratory. We have Christian Aramayo, Chief Operating Officer of Kuya. And last but not least, we have Marku Teras Vasara, President of Minerals Metso. So without further ado, I'll just dive in. I'm going to ask Saud our first question, and then we'll keep this conversational. I'll stimulate some questions and thoughts, and please feel free to be as contentious and as challenging as possible, for that's what creates change. So Saud, how are data and AI allowing us to have greater insights in exploration, processing, and autonomy in order to drive down costs and maintain speed of operations?
Thank you, Jim. First of all, I'd like to welcome you all to Saudi. If this is your first time, I hope you're impressed by the transformation that's happening in the country, including the mining and metals industry. And if it's your second time, you've been to the FMF last year, I hope you see the momentum, how it's keep building up from last year, and the growth in the industry. Technology, very interesting subject. I think if you made it to this room, you must be an enthusiast, or already you're within technology, whether in the industry or not. So I'm not going to get too technical into this, but let me just state that data and AI have truly been unlocking value for this industry in different applications across the value chain and in very important aspects of safety and sustainability. With this said, we all understand the amount of data that we get into industries that have been enabled by the I 4.0 industries when it comes to the IoT sensors, when it comes to the technologies that enable us to compile data from our operations. But more interestingly, some of the recent practices that we are adapting additional technologies to pile up even additional data. So we are not satisfied with the data that we have, because if we know AI models to be tuned and to be optimized, they love more data, because more data give us better performance in the models of artificial intelligence. They give us greater confidence in the predictions that we have and more optimized models. So with this said, I'll just state a few examples just to enlighten the discussion here and probably open the door for other areas or applications within the industry. So within the exploration, so the use of drone technology and how it's been helping us truly to collect data into the electromagnetic, doing some of the surveying. There's not only very much some research say 5 times faster collecting some of this data, but it's producing more accurate data. This is what truly matters. More accurate data give us better predictive models of the deposit locations that we can explore and mine for, and then reducing cost and reducing time for this. Other areas of operations when it comes to predictive maintenance, digital twins, and how it enables us to do a lot of the simulation and forecasting that truly enable us to reduce cost, maintain productivity, and throughput. Safety, you name it, or the use of wearables on our workers and our drivers, the use of GPS locations of the haulage trucks and the routes, truly enabling us to compile very important data that once employed into certain models targeting safety and preventive safety, it will truly help us into better keeping our workers out of hazardous way. Last but not least, the sustainability, and we all understand, I think, the pressures of sustainability to decarbonize the industry and reduce the emissions. Truly, data is still helping a great role there, because it truly enables us to see and visualize how we are keeping up on this journey and the targets that we are putting, and then enable us to do predictive models to truly track our progress toward achieving our net zero carbon neutrality objectives.
Saud, thank you very much. That was a very comprehensive review of that flow of the information technologies that we can bring and apply to the other processes that we're using in the industry and how we can adapt and improve them. And when we're talking about flows, particularly the flows of energy and the flows of water are critical in the mining sector. And so I would like to ask Brian and Christian respectively, in terms of energy and water. Brian, What do you see as the main thrusts of technology advancement in the better management of energy utilization in the mining process?
Well, I'd also like to thank the organizers and thank you, Jim, for having me here. We're at the National Energy Technology Laboratory. We are the U.S.'s national lab that's been doing mining since 1910, since our founding. Today, a lot of our focus is on individual technologies that help reduce the energy footprint, the carbon footprint, and the total environmental footprint. And many of the technologies Sauda already touched on, whether it's the development of new sensors that are useful in extreme environments, whether it's a corrosive environments, high temperature, high pressure, subsurface environments that have high enough resolution to pick up some of the small components, whether it's the components, the impurities that we want to avoid to enable real-time processing, as well as feeding into large data analysis, machine learning, artificial intelligence. And one area that I wanted to bring up is specifically in the area of prospecting, where one big effort that we're working on is how we put together different data layers in a geostatistical, geospatial data analytics method to better predict the hotspots for things like critical minerals and rare earth elements. And so in sedimentary basins, when you layer on both the sedimentary geology of the depositional environment plus the measurements that we can get from boreholes and from existing known mining concentrations, we start to be able to develop a better predictive model of hitting the hotspots for mining. And that in itself helps reduce the environmental footprint and potentially enabling the type of in situ mining that we may be able to achieve. That think of it as laparoscopic. When we look at the unconventional hydrocarbon space, we've had great advances in horizontal drilling and fracturing, and we think that combination of extractive methods with a smaller surface footprint while doing some in situ mining for critical minerals, it really could unlock a great potential. And as I pass it to Christian, because I know one big area for us is unlocking the potential in unconventional sources. Yeah. The unconventional sources being a lot of opportunities for tailings, reprocessing, for flowback and produced waters from the oil and gas sector, for extraction of other minerals. And for us in the U.S., we've really tackled on coal mining and coal waste, coal tailings, acid mine drainage, sludge, and the ability to process already environmental legacy impacts to then extract minerals from those unconventional sources.
And so it's more about the specific energy efficiency of utilization in specific areas as well.
Yes, absolutely. So all of these individual technologies have been put together in the total mining system create the increments that we need to bring down the energy footprint of the mining system, as well as reducing the waste that are then require a heavy energy footprint on the processing side.
Good. And my apologies, Christian. Please hold. Marku, sorry, I want to ask you on the water front, on the water flows. Please tell me, in parallel, as we're managing and better utilizing the specific energy and the footprints, how can we improve our water utilization through the use of technology? Very vital for the region here.
Yeah, I would agree. Thanks, Jim. And I would agree that this is very burning topic for the area. And at Soutotec, we are in the value chain, starting from basically comminution, going down with separation, dewatering, and then finally metals refining. So if you look at the concentrator plant process, that is a number of individual equipment operations that consume water. And ideally, if you take the highest approach, of course, ideally, ultimately, we would like to have a concentrator plant only applying dry separation, but we are not there yet. So then we need to look at what are the next steps, and then taking a step down, of course, almost all the material that we are processing in a concentrator plant will end up in a tailings pond or somewhere where you store your waste rock. So if you can process less material by pre-concentrating it or do you applying sorting, then again you avoid consuming water. And then of course if that doesn't help, then with the process as such, what really is the problem in concentrator plant in water management is actually the fines. So if you can separate your ore or metal from coarser material, again, you will have less problem with water. And ultimately, you will come into the tailings, and then with help of thickening, filtration, recycling in the water as such. Yeah. That has some problem because you typically accumulate some of the substances that actually will make flotation process a bit less efficient. So you need to have the knowledge to take those away, and that is one area definitely we are working on. But these are the kind of steps in various orders, and then also applying. I think it was already mentioned that what, as an example from Saudi Arabia, for example, using other water sources. So we are at the moment building a plant here which will use community wastewater as a process water. We will purify that. We will take away the particles that are harmful for the flotation, and then use municipality wastewater for processing. And you can use seawater, or you can use from the oil industry, as was mentioned. So there are plenty of ways to take care of the water problem, and I feel that this is really coming an important topic in many areas.
Thank you, Markku. Before, Anna, did you have a particular comment?
No, it's a very refreshing point that was made by Metso, because in addition to running Sigma, I'm the co-founder of the fund that controls it. And when we decided to build the concentration plant, which is basically commissioning now, we had to make a decision. And it was a very hard decision technologically that was based on environmental ground. In other words, we chose dense media separation versus flotation because the purpose of my fund was to eliminate tailing dams to begin with. Right. So dense media separation allowed us to more easily plug in the thickener and the dry stacking circuit. And we were the guinea pigs with the supplier to test the ultrafines dry stacking, which just shows that in 2022, we were the guinea pigs of the dry stacking circuit, which means no one was focusing on processing technology as a means to reaching sustainability. And now that there's a lot of focus on increased recoveries from flotation, flotation, DMS, hasn't received any investment in like 30 years. Our fund was one of the few ones to deploy capital in clean tech and green tech as it applies to processing and to separation. We took that DMS technology, which is borrowed from diamonds, basically. It was sort of used in lithium, but just in half the separation of lithium. The other half was flotation. And we made it a whole concentrator separation technology by automating it and then digitalizing it. We built our own algorithm. But the point is, no one had done it. Yeah. So part of the fact that Sigma became such a success is resulting from the fact that we actually took the risk of investing in separation technologies, processing technologies, when it wasn't really fashionable because of environmental concerns. Believe me, no one cared. In fact, people thought that we were a bit odd in even deploying capital and forsaking recoveries on the grounds of environmental and sustainability concerns. This was just 2019.
So you know what's fascinating about what I've heard so far, and Christian, forgive me just to interject here, is that, if I'm not mistaken, it seems to me that the application of effort and technology and process earlier in the stage can increase the leverage of that technology for both environmental and cost benefit.
Yes.
And traditionally in the mining sector, because we have not, over the last 50 to 75 years of the industrialization curve, we've not really worried about the environmental factors up until maybe a decade or two ago. So we've gotten into this lazy fashion of creating lagging technologies that push the problem to the end, where we've got these huge tailing dams that nobody cares about. And what I'm seeing with all of this commonality of insights is that we're actually using technology to draw our efforts earlier on in the process, so we're manipulating less and less waste and focusing the energies on the key aspect of mineral as early as possible. And if I may, Markku, just Christian, how do you think that affects the whole cost structure and capex and the capital deployment of where we might go with this?
Okay, first of all, I want to thank you for being here. I think that cost is being increasingly benefit from technology because it allows us to surgically extract certain things that were not able before. For instance, although I do agree that the environmental is a very big concern, talent attraction, I think, is also very important in mining industry. We are not, let's say, the most attractive or welcoming industry for younger generation, and that is because working conditions are tough, including safety. Robotics is helping us a lot in burying, for instance, in doing an underground mine. You don't want people to be burying there, drilling and blasting. We're using robots to start doing that, automating process as well, as Anna was mentioning, not only reduce the amount of energy, but also reduce the size. Let's say if I can automate 2 scoops going into an underground gallery, I can make the gallery by itself smaller, meaning that my footprint is smaller, my capex is smaller, because remember that big portion of my capex will be the development of the underground facility, talking about an underground mine, until I get to the vein itself. So if I can make everything smaller and also cost efficient, because the robot and the automation will actually be built to go in and back in the same way, therefore energy will be reduced. The only challenge will be how this robot will interact with people, because I cannot take out of people of the mine, because I will get in a big social problem. Because although I would try to make everybody working from their office and everybody comfortable in wherever they are living, we cannot do that, because we know that in several places of the world, like South America, where we are basically located, that will create us conflicts. We want them to be as safe and efficient as possible. And that will help us also to manage water in a most efficient way, because if we can automate the process and we can have robots doing all what we should be calculating, estimating, let's say, and readjusting, then my water usage go lower. First of all, maybe if I have less people, I need less utilities in an underground facility, therefore less water. If I have robots, I create different jobs. When people say we're working in mining, they don't necessarily need to be working on the mine. They will need to be learning how to weld, for instance, nickel alloy welding for the robots, or all the kind of alloys that you need, all the circuits that you need to build, and the network that you need to build for the robot to interact, the EA, all the neurologically connected synergies and synapses that the robot need to have in order to act, will create traction within the younger generations, and as a result, also with environment.
And you know, I couldn't agree more, because you know, Christian, we resonate very much, because the philosophy we have at Offworld, for example, in the deployment of our autonomous swarms of mining robots, are to liberate the mineral as close as possible to the original rock face as we can, and move waste rock as few meters as possible. Mm-hmm. And so literally, eventually, we just want our treasure bots to bring out mineral on ingots, and that will be it. So that I think the opportunity exists with everyone on this panel and all of us working together. The opportunity exists within a decade to turn the process of mining from an industrial, intrusive, penetrative, dirty, non-environmentally sensitive sector into an ecological, harmonizing process that both maintains the environment, reduces cost, redefines how people work into much more inspiring and future-facing jobs, and bringing technology into the place so that mining becomes not only the sexiest industry in the world, but the most environmentally reconfiguring sector in the world. We can actually turn mining into a net positive from a cost, education, cultural, and environmental perspective. And I think that's a huge opportunity we have. Now, how do we bring that narrative together so that all the pieces of the puzzle, from energy, from water, to automation, to data, to even, as you say, excuse me, the culture of the workforces in these regions where their whole livelihood is dependent on these mines. How do you reduce that fear and allow the community and the social contract to then meet that future as well? So, Anna, please.
You need purpose. I mean, you need long-term, purpose-driven capital. That's why I think the JV between PIF and Madden was so exciting, because that's the kind of capital I have under management.
Right.
And we've been, well, Sigma's been held like this for 10 years. We've been there for 7 years, and we don't have an exit sort of obligation. But we took it through the cycle irrespectively of the price cycles, irrespectively of the capital markets, because there was that purpose of building. I mean, we're not a mining fund, we're an impact fund. And when our peers ran away from the sector to do inclusive digital because mining had single-handedly lost its social license in Brazil as a result of tailing dams collapsing, we went straight into the heart of the problem with the apparatus we had on technology and with the apparatus we had on sustainability, the matrix, social, environmental, to solve that issue.
But this is unusual because you started a fund and then you dove straight into the center of the technology problem as well.
Yeah.
I mean, in some ways, it's another way that Martin and PIF coming together.
That's right. We've had the fund, but that was exactly the idea. We had the fund. We were going to go to do fintech like everyone else in 2016. And then this happened, this first tailing dam collapse. And we said, why should we as an impact fund be doing digital inclusion versus let's just go solve the issue? Because in addition to that, you have climate action. So mining is key to decarbonizing. We saw this in 16, but now I think it's pretty clear to everyone that without mining, there's no energy transition. So how do you reconcile this? Exactly what you said with sustainability, where everyone is happy. You lift communities. But what does it take? Well, it's huge effort. Why is that? Because you're doing it while you're not producing revenues. This is sort of how you avoid a legacy. That's why I think the opportunity here is so large, because you're going to build it right from the beginning. So by the time you produce, you're not going to have a contingency from your decisions made during development, during feasibility, during when it's really hard, because you don't have any money, you're small. A lot of these juniors are hostages to capital markets. They don't like to hear this. So you need that sort of, let's say, backing. It's not a coincidence. A lot of our investors are from the region, right?
Right.
That long-term thinking, that alignment, so that you build it right.
So to Saud, just briefly, and then please comment as you wish as well. I mean, Saudi, the kingdom, I think it's fair to say, is a fairly young mining kingdom, but with a very forward-looking ambition, very progressive thought process, and the financial and intellectual resources to lead the way and make a change. How do we, or how, for example, is Martin and the kingdom going to take mining forward with all these technologies without pushing us over the climate cliff to try and extract all the materials needed to not push us over the climate cliff?
Excellent question. So technology is not the solution by itself. So technology is part of the equation.
Yes.
We heard the need for the talent. We heard the need for the investment. We heard the need overall for a vision of why we need all that. And I believe that has been established with the pressures of the decarbonization that we all realize for the planet, and also for the critical minerals that are required for the energy transition that is happening.
Yes.
So when we talk about technology, yes, very crucial. However, the talent behind it and attracting the talent that is required, we are seeing influx of data scientists walking into the industry as an example, in addition to technology experts and robot experts and so on. That is definitely is helping the industry move on and truly leapfrog into the targets that we have established rather than the small steps required.
Very good, very good. Good. Then, so look, in the last few minutes, would members of the panel, or even if any of the members of the audience have a burning question, any points to raise or close with on particularly how we're bringing all this technology and innovation together? What are the real, maybe one question I might have, if there are no takers, what is the most challenging problem, and bearing in mind it's not just a technology issue, what's the most challenging technological problem that we need to solve?
I think that one of the problems that we need to solve is thinking the problem first and the solution later. As I have seen a lot of minings thinking, I'm going to use electric cars or scoops to go from one place to the other. So that's not solving the problem. You should ask, why should I move, as you were saying, to try to use the less effort, why should I move first? So once you understand that what you're trying to solve, then you can bring, as Saud said, the technology as a tool. You can bring one supplier, you can bring the fund, you can bring whoever once you have what you have to solve. So right now, I think a lot of people are trying to rush into technology without even understanding what they are doing or why they are doing, and that by itself will make projects more expensive.
Especially at a systems level.
Yes.
Marco, please.
Yeah, well, I'm an optimist, so I don't talk about challenge, but an opportunity. I think, of course, we know that mining is quite conservative industry, so we need to. But I feel a change. So I think people are willing to change. The environmental sustainability issues are higher on agenda. Maybe we don't always need to do the giant leaps. We can do small improvements in everything we do, and then ultimately resulting in good way. Quite often today already you can steer things by regulation, but you can also develop products like what we like to do. In all the new product development, we have sustainability as number one criteria. So and that is getting a lot foothold. So when we see that we can do even a 10 or 15% improvement on energy consumption or water usage or something, those products has become extremely popular at the moment. So we are getting good traction on that. So I'm hopeful.
Very good. And Brian?
So I have one, and it's really for our ESG technologies to keep up with demand. Because as you're alluding to, we're looking at for critical minerals, let's say lithium maybe an 8x over the next 20 years in terms of demand, everything from cobalt, nickel, manganese, graphite. We're looking at maybe a 4 or 5x demand. And we're also going to be moving to lower grade resources as we move down the resource curve. And so for us to be able to develop these technologies from the beginning, that then we're in not moving as much waste material in the end, we're going to have to move technology forward to keep up with that demand.
If I may add, they say every challenge can be an opportunity. I think the opportunity for us, not only in technology within the industry, but also from the different elements within the industry, is to collaborate and to have partnerships. I believe the number of the agreements and MOUs and in this event by itself, and we're only the first day of the event, reflects the level of collaboration.
We could tell by the delay.
and how this is important into the way forward, and to have accelerated steps to truly leverage previous learning curves.
It's a huge problem. We can only do it together. Anna?
No, it's the same. I think I'm an optimist, and I think 2023 is probably one of the most exciting years this industry has ever seen, because you now have the three main markets fueling, like, on 12 cylinders, right? It was just a China story, EVs, when we started. Then it became China in Europe. Now you got China in the US. And then you have the Middle East offering this platform for the processing, for the midstream, powered by Scope 2 that's zero carbon. It's natural gas and abundant renewables. So solar. So it's the perfect location. So I'm very excited about what's happening here. I've been coming to the region for a while, but this is fantastic. And ultimately, it's the collaboration, because each party brings something to the table. I mean, for example, where we come from in Latin America has the minerals. But then here you've got a very stable jurisdiction with this mindset of green mining, with technology. And it's a platform that's, basically friendly to the East as well. So you actually access 100% of the market once you set yourself up here for midstream chemicals processing, but differently than before, with the carbon in mind. So probably Saudi Arabia will lead the decarbonization of these critical materials, I think.
Wonderful. No, very beautifully said. And look, with that, I would like to thank our amazing panel. It's a privilege to share the stage with you and the amazing work that everybody is doing. And as you say, Saud, we need to work together and collaborate for this future that we're building together. So thank you very much.
Thank you.
Thank you for your patience and your attention, and enjoy the rest of the event.
Thank you.
Thank you, Jim, and the different panelists for this wonderful conversation, setting the stage about how technology can solve some of the main issues in the region and helping the mining sector in Saudi Arabia become one of the leading in the world. Thank you very much. Now, what we're going to do for the next few presentations is actually to be able to drill specifically on some of those unique technologies that are going to be leading mining in from Siemens. Niels is actually the head of Global Account Management and Target Projects. He's going to give us a presentation during 10 minutes on de-risking and accelerating mine commissioning with prefabricated e-house solutions. Please join me on stage.
Can we switch on the mic? Test, test, hello? Working? Ready starting? Okay. Also very warm welcome from my side here. Niels Janssen, thank you for the kind introduction. I'm heading the global account management in Siemens for our minerals clients. And I brought, as already presented, the topic to you, de-risk and accelerate mine commissioning with prefabricated e-house solutions. So long title already, spoilers a little bit the content, but I want to explain to you why I've selected this topic for this presentation. So when we look into, or we are here in this 2 to 3 days to look into untapping the natural resources other than oil and gas in this region. And with that, we look into the mineral sector, which we need for our energy transition. Siemens itself, as producer, as electrical manufacturer, uses a lot of copper, steel, other minerals, right? So we definitely need the source to further bring the energy transition ahead. And when you look into a mine of the future, and I can really thank the previous plenary here, talking about digitalization, this is one of the key trends, digitalization, to make the mine of the future-proof. Second big topic will be the electrification, and that fits perfectly to this presentation. So we have also learned in the previous plenary that digitalization is all about think about why should you move material and minimize it to an extent that it's useful to make your process happen. But in the end of the day, you will need to move material. And to move material, for example, in a conveyor belt or in a mine winder, or later and to process it, for example, in a mill or in a crusher, you'll need actuators, motors, big electric motors, which need to be powered by more sensitive equipment. So we are looking here into mines, especially into these regions which will be set up at high ambient temperatures, dusty environment, maybe even high humidities. And to control a motor, you need motor control cubicles, you need PLCs, you need the switch gears and medium voltage VFDs. And these equipments need to be protected from the net environment. How is that done in a classical way? We talk about a substation, so more buildings, concrete buildings, which are built up. And then after those are completed and constructed, the electrical equipment, VFDs and so on, what I've just mentioned are put in, are wired, are tested, commissioned, and then put into operation, all in the hectic environment of a new construction site of a mine. And this gives us already a couple of headaches or risks at least. First risk or headache is how do you organize all these components which you have to install bit by bit and piece by piece in your substation. So you have to have the organization, the logistics. Secondly, you have to have the specialist on the site at the right time, at the right place. 1 point, organization. Second point is how do you assure that during your construction, during your installation, the ambient conditions are kept under control. Now I'm bringing in equipment in a substation, doors are open, dust can enter, and so on. So you might have an impact on the lifetime already of the equipment during the installation. And the idea here is to overcome this particular headaches is a prefabricated EOS. What is it? You see here the pictures. I hope I'm not in the middle here of the picture for the audience. It's a steel enclosure, a structure, a container, which I can build in a controlled environment, a factory, and where all the electrical equipment is installed inside of this factory. This whole unit is then be able to be shipped to the mine site. Exactly. And with that, you can decouple basically the construction of the mine from the electrical equipment. Now you have one single lift or one single ship of your electrical equipment, and you have a plug-and-play solution at site where you just connect the wires, the sensors to your controls, to the e-house, and can set this whole beauty into operation. Exactly. So the whole idea here is, with that, you can decouple, like I said already, the construction, which means you have a positive impact because of parallel construction and operations of your whole mine. And with that, you can also assure that you have the right specialist at the right time, as in the factory where the e-house is produced, right? And with that, you can save time. You can also save CAPEX costs, because now the specialists do not have to travel on site. A lot of installation, wiring, and even pre-commissioning can be done in the factory itself. And last but not least, in the factory, you have a controlled environment, and you eliminate the risk of any issues with ambient conditions as far as possible. So how does a typical timeline of such a construction look like of an e-house? And how would the ideal partner for such a construction look like? We see here typically you have, I forgot, sales, then we have the engineering and so on. I think that these are the typical steps which you have, and you want most of these steps being localized. Why? You want to have your contact partner close to you, close to the mine site, who can educate, who can service, who can consult, who can engineer that. And if there are special objectives to achieve, a first of its kind, special engineering required, then you want to have a partner which can bring in the local, global expertise locally, who can transfer the knowledge from the global expertise, from the reference in a global manner to your local mine site, makes the team, the local team, ready to execute, and then for the next projects ready to do it by themselves. No, one back. Here again, I want to emphasize the localization. So especially here, to mention Siemens also, there are local partners for the e-house construction, which can, with our components, build that up, all under local engineering, project management, execution, and also major components like, for example, switchgears, where a manufacturing facility in Jeddah is existing with more than now 10,000 medium voltage panels are installed, can be delivered here directly from our construction site to the e-house supplier to finalize that. I'm not sure about the time, but this is my presentation. If you have any further questions to that, want to deepen the discussions, we have a complete team here. You find us in the gold sponsorship area. We are happy to answer your questions there, and thank you very much for your attention.
Thank you very much, Niels, for this presentation on prefabricated e-house solution. I appreciate it. Without further ado, I'd like to turn to the next tech talk with Hartono Vijaya from Cyanco. Hartono is Senior Vice President of Business Development and Strategy. He's going to make us a presentation on using less to extract more, safely and sustainably. So please, Hartono, if you can join me, the stage is yours.
Okay. Good afternoon, everyone. First of all, thank you to Future Minerals Forum for hosting this event. So my name is Hartono Vijaya. I'm the Senior Vice President of Development and Strategy for Cyanco. It's a pleasure to be here today. So a bit of background on Cyanco. So Cyanco is a global leader in mineral extraction chemicals for the gold and silver mining industry. So sodium cyanide is the one chemical that the gold miners use to extract the gold from the ore. So making it the one chemical that it must have to function. So without sodium cyanide, mining operations, gold mining operations literally grind to a halt. Cyanco currently have 2 production facilities with 5 independent production lines based in the US, and this coupled with distribution terminals strategically located really provide our customers with unparalleled security of supply. as part of our value proposition to our customers, we do have a suite of technical offerings. These range from cyanide analyzers to optimize the use of chemical reagent, to detoxification study to ensure that no harmful chemicals are released to the environment, and also sharing of best practices in the use of sodium cyanide. And this unique offering really differentiates ourselves from our competitors, and which is why Cyanco regards itself as the only Tier 1+ supplier of sodium cyanide to the mining industry. A bit of process check. So sodium cyanide can be used in 2 different systems. The first one is what we call a heap leaching, where sodium cyanide solution is typically dripped into a heap leach pad, and then what we call the pregnant solution will go through downstream processes to extract the ore itself. The second system is a vat or tank leaching, so a similar concept where the ore is mixed with the sodium cyanide solution, and again, it goes through downstream process to extract the gold. So Cyanco plays a role, an important role in the mining value chain, right? We are obviously a raw material supplier as opposed to a transportation vendor, equipment manufacturer, or the IT and system providers. So mining has really evolved with increasing accountability and responsibility, with a strong focus on ESG. So Cyanco can really play a part in this journey with the miners itself through a combination of revolutionary technologies or evolution of systems and processes. So I'll take through some of these examples in this brief presentation. So this graphic here shows the circular economy. This is as opposed to a linear economy where it's about the raw materials coming in, extraction of the minerals itself, use of the minerals, and then ultimately waste disposal. So in a circular economy concept, it's no doubt that minerals and metals are critical and will power the circular economy going forward. But it's equally to understand how the minerals are explored, mined, processed, the raw materials, how it's getting extracted, getting production, and more importantly, how it's used, reused, and recycled. In each of these steps, Cyanco has examples on how it can play a part, an important part in this circular economy. So this could range from processing, where we help our mines to stay safe, sustainable, and be compliant. We also look into continued investment in alternative lixiviant technology, exploring alternatives. In production, Cyanco has a strong mindset in continuous improvement, which is anchored through concepts such as lean methodology and Six Sigma. And finally, Cyanco do provide multiple packaging options, right, such as isotainers or solution tankers, with a view that these containers could be reused, as opposed to a typical packaging which has to be discarded as waste. So this is how Cyanco can play a part with miners to be successful in this circular economy concept. I'll spend the next 3 slides also deep diving on some specific examples on some of this circular economy concept itself. So Cyanco is a founding signatory of the International Cyanide Management Code. So what this code is basically articulate the best practices in the safe use of sodium cyanide, which includes manufacturing and transportation of sodium cyanide. What we do for our customers is we help them to obtain certification against a code and also recertification. So you might ask, well, how does this help the miners itself? What this means is obtaining certification will provide the assurance process that the miners will be sustainable in terms of its safety standards and being environmentally responsible, which is super important. So Cyanco has demonstrated successful case studies to that effect on how we help to optimize the mining operation. This includes the use of sodium cyanide itself, which is a chemical reagent. So as ironic as it is, because Cyanco is a producer of sodium cyanide, but we are helping our customers to reduce the use of sodium cyanide itself. So the way we look at it is that what makes our customers successful makes Cyanco successful as well. And ultimately, we're doing this for the better, for the world of good, where we look to optimize mineral extraction, but at the same time, we minimize the use of chemical reagent. detoxification. So once the sodium cyanide has gone through the leaching process, there's residual cyanide which has to be treated, and we call it detoxification. Cyanco can support its customers through various steps such as detoxification study, and also supply of detoxification chemical to ensure that no harmful chemicals are released to the environment. So this is the last slide here. So with a high level of accountability and responsibilities, mines and their suppliers are fully focused on sustainability strategies, which will carry them forward into the circular economy. So Cyanco, with the unique offering of the sodium cyanide product itself, but also with the applied technology services, will go a long way to ensure that the miners will be successful in this approach by ensuring that they're operating with the highest safety standards, being environmentally responsible, and ensuring regulatory compliance, and ultimately also reduce waste. So we have a booth here. We would love to talk to you on how we can help you to be successful in this journey. This is anchored in operational best practices, and also in a full circular systems view. Thank you.
Thank you very much, Artono, for this presentation. Very interesting presentation on the use of cyanide in the circular economy for mining operations. Without further ado, I'd like to turn to Cyriac Joseph. Cyriac is a Managing Director and CEO of Squadron Infra and Mining PVT. He's going to talk to us about drone technology, how digital transformation through AI and ML can be important in mining and tunneling.
Yep. Digital technology through AI and ML in mining and tunneling. Drone technology, we are from Squadron Infra and Mining Private Limited. I'm the MD and CEO. I'm a mining engineer and a drone pilot. So we focus on drone technology in mining and exploration mining, both underground and open pit. We're tied up with, partnered with MSN Australia for drone technology in underground mines in India, and with the Stryos USA for AI and ML in mining in open pit. So we're in 10 countries, present 10 countries, 800 mines, 50 customers. So this discussion will be taking it through 3 sectors. One is drones in geophysical surveys, drones in underground mines and tunneling, and application of drones in surface mine using AI and ML. So first, let's look at the drone-mounted magnetometers or drones in geophysical survey. So here what we do is, right now, we just plan the flight path for the particular area of interest, and then we use a magnetometer suspended on a drone. And then it just flies. You don't have to enter the area. It is very quick. It doesn't, so it is best for inaccessible areas. The flights are autonomous. You can prospect in forest areas without entering the area, without even touching the vegetation. You can even, no need of any approach roads because it's got a range of 7 kilometers. You can always stand out and do that in thick forest, marshy areas, no crocodiles, no wildlife, nothing. You just do not have to expose to anybody. You got to follow the terrain. It just goes as if low as possible, low flying up to 1 meter, and then slow flying, rough terrain, thorny bushes, not an issue. So this goes straight into this, very high resolution outputs, and with a sampling rate of 1,000 samples per second, you can fast track your exploration, extension of existing mines and ore deposits, and then you get very good magnetic anomalies and contour maps and 3D outputs. So it's a fantastic tool. So here, again, I told you it's wonderful for capturing large areas, particularly for lithium, copper, gold, nickel, iron ore, and then it is very quick to demarcate land acquisitions. Prospects 600 to 800 meters, and then mineral projects which took 10 to 12 months, you can do it in just a month, and which took 3 to 4 years, could be completed in 5 to 6 months. And then specifically establishing mineralized zones. Prospect versus reject. Now most prospecting takes time on rejects. So here, what happens is you can directly go and focus on the prospects. So that's the best part of it. You can see the difference between fixed wing and drone magnetics. You need to, fixed wing flies at 200 kilometers per hour, whereas this goes at 10 to 25 kilometers per hour. Your flying height, in case of fixed wing, 100 to 200 meters. Here, it line of 100 meters, line spacing, 10 samples per second, whereas same thing, you can fly 1 meter to 25 to 50 meters, whatever you want. spacing 25 meters spacing, low flying, slow flying, follow the terrain. And then you got the drones in underground mining. Squadron first to fly autonomous drones in tunnels and underground mines in India. So it's a lidar slam-based technology. From it's got a scanning range of 250 to 300 meters. Does total autonomous flying. Your pilots can be stayed in a safe point and just launch it with a tablet. You get 3D map the environment in real time. It goes beyond line of sight. GPS denied areas. Personnel can remain under control. It could integrate the surface features and underground features. Once you got the output, you can integrate the surface features and underground features, plunge into it, take an immersion view, everything about 5 mm accuracy. Yep, and then you could even do the mapping in real time. You could get it as you map. You can get it. Doesn't need any line of sight or whatever it is. Keep your personnel safe and map the stopes. High levels of safety of the miners. Then 3D view of underground metro. So you got the surface features and underground features. You capture it with lidar and then you integrate it to get the best output. And then now you can see the advantages. Stopes, you can get perfect volumes, dimensions, particularly in stores where there's no other way of entering. You could use this tech, nowhere comparable to CMS, and then you can easily, safely map it. Use for overbreaks, underbreaks, backfill volumes and profiles. Then underground mine rescue. It goes without saying. It's a beautiful tool. Coming to exploration of old workings, you can assess the health, roof support and rock mass. And then as built, you can always check you can always build back based on that. Is it not working? Tech team, can you just 2 more minutes? It's not working? It's not working. Stuck. I think I'm running out of time. Okay, so we are with, okay. Okay, this is the final one, which I'll just take 3 more minutes and close it. So we are with the drone. This is basically in mechanized open pit mines, where you could use, see any drone data, 20% is just data capture, but the real benefits comes from 80% of the analytics. So here with Strios, it's a cloud-based platform where you just got, in case of traditional method, you got about 7 to 8 steps, whereas here you just upload the photos into your platform and you get detailed analytics. So let's just a video of this. It can look, you take a mine, and large mine, and you can get the width of you can map the entire roads, you can get the gradients, the width of the entire road every 5 meters. You can get the bench levels at every 5 meter. You could go and measure the height of the benches or the dumps at wherever, any location. You can take the width. Yep. And then you can even mark the safety zone if you blast each day and caution beforehand that this is going to be a blasting zone. And so that, you can caution your people. You can get sections at any point along any alignment and analyze the slopes. Stockpile management, beautiful. It just click of a button, it gets your stockpile any size, anywhere, lying anywhere in the mine. It not only gives you area and the volume, it also gives you the exact 3D profile of the stockpile. So this you can get similarly pre-blast, post-blast, and you can do a surgical analysis of your blast. It can go back. It doesn't need any high-speed camera. You can go back and see. So that's with this, and I think I'll skip this. It's all app-based, so you can analyze you can just have total control depending on. You can get a perfect phase profile of the burden, plan your blast, and fragmentation analysis. You can log in from anywhere, work from anywhere without internet, and the formats you can get in any format: AutoCAD, Serpac, Datamine, or any format. Finally, improved safety, cost saving with enhanced efficiency, informed decision making. Thank you. So we sell informed, innovative solutions. We don't sell drones. Please visit our stall. It's at the right at the corner there. So you need to take some time to come around and reach us there. Thank you.
Thank you very much, Cyriac, for this presentation on the various roles that drones can play in mining operations. I'd like now to turn to Michael Zdanov. Michael is Chairman and CEO of Technol Maging. He's actually going to talk to us about the importance of innovative airborne geophysical technology and other technology in the field. Thank you.
To move forward, just remind me.
I think it's this one.
Okay. Okay, thank you for introduction, and I really would like to thank the organizers of forum for invitation to give presentation in this very important meeting. And I will speak about some innovation in airborne geophysical technology. No, I would like to start that airborne geophysical methods are extremely important because using airborne techniques, we can cover large area very economically with limited cost and obtain results which otherwise very difficult to get using the ground data. However, until recently, most airborne data was interpreted only in terms of actually maps of the observed data. For example, for magnetic data, magnetic maps were analyzed. For electromagnetic data, very simplistic laid Earth interpretation was done. This example of the map of EM data collected in the alien Democratic Republic of Congo, and target was conductive mineralized black shale. But if you look at this map, you cannot find the shale because these maps will tell you even horizontal location, you cannot see this. So important, and this will be focus of my presentation, that of course very important to collect good data using drones or helicopters or fixed-wing airplanes, but then what to do with this data? And this is actually the subject of my presentation. Because in fact, what you can do if you apply computer simulation, you can simulate the physical geological property of the subsurface and predict the observed data which would be produced over specific geological formation. And then you can compare this data with your observation. And by iteration, you can get very good fit. And then you will get real 3D model of the subsurface. And this is a horizontal slice of the 3D model at a depth of about 300 meters. And then you can see the shale. So you can compare. Try to go back. You can compare. This is what you see in the map, and this is what you can see after interpretation. So it's a huge difference. And so this is what is my talk about. And actually in this talk I will review some recent developments and identify those advances which have resulted actually in paradigm changes in airborne geophysical surveys. There are two aspects. First aspect is collecting multi-physics data. Because, you know, until recently, people collected magnetic data, but they are responsible for magnetic properties of the rocks. Or gravity data, they will give you information about density. Or electromagnetic data, they provide information about conductivity. At different sides of the same geological structure. And each of these techniques provides very non-unique solution. We know very well, geophysicists, that you can find many models which could generate the same data. But by using multi-physics data, we reduce this uncertainty and we come up with more reliable, more robust solution. So this is the first advances. And second, of course, this what we call in geophysics inversion. The process which I described before, constructing the 3D model of subsurface based on computer simulation, in mathematics and geophysics called inversion. And what is important, 3D. Because there are quite a few techniques out there for very simplistic model of the Earth, like horizontally laid Earth. But what we develop full 3D realistic modeling of subject using all different type of the data. As a case study, I will show the results of the project which we conducted here in Saudi Arabia. We call it Glass Earth Saudi Arabia project, and explain you later why. But before, I just show a simple picture. This is airborne geophysical system, And it could, we can use different platforms, fixed wing, helicopter, drones, and different sensors, magnetic, gravity, electromagnetic, etc. As example, airborne platform, for example, how it works. You have airplane, you have this shown by red transmitter loop, it generates the pulse of arithmetic signal, it propagates through the earth, then reflects back, you measure the response, you obtain the data. But the key is how to transform this data in the model, in the real geology. And this is what we were working. We will develop joint inversion of multiphysics data. And this joint inversion much more powerful than the results provided by individual data set alone. And so this is really very powerful technology for risk reduction and success of the discovery of mineral deposit. Now, as illustration, I will speak about this project which we conducted in collaboration between Technoimaging. Actually, Technoimaging is a US-based company. We located in Utah, in Salt Lake City, and KAICC, King Abdulaziz City of Science and Technology, here in Riyadh. So we conducted this survey, which involved acquisition, processing, interpretation, airborne EM, gravity, magnetic data over about 8,000 square kilometers area over Arabian Shield. And the goal was to study the top kilometer of the Saudi Arabian Red Mass to provide roadmap for natural resource exploration in this area. So this is workflow of our project, but I think this workflow can be applied to any geophysical survey. You start with country scale. You evaluate, geology and prospect of different areas of the country. You select the area for regional study. Then you go to regional scale. You conduct a airborne survey over about areas, many thousand square kilometers. Then you go to deposit scale. You conduct more detailed survey on the area about maybe 10, 15 square kilometers. And then you drill. So, and this is where we have this green effect, because instead of drill, and having hundreds of drill holes, very expensive and very environmentally damaging, you select the optimal position of your drill, you save money, you save environment, and you have the best product available. So the first stage, we analyzed with our colleagues in KAICC general geology and selected area shown by red. It's close to Medina. Actually, there are quite a few very well-known mines in Saudi Arabia. Solomon mine is nearby, by the way. Mahal Dahab. I'm sorry, my Arabic is not good. So anyway, so we selected this area. It's, as I said, 8,000 square kilometers roughly. So then, next step, regional scale. So we flew on survey. This is the lines of the survey. This airplane, this data acquisition was done by our partner, Spectrum, South African company. So they collected this data. And we process, quality control, analyze the data, design survey, worked jointly with them. They acquired the data. These lines and flight lines over this area, so this regional scale. So we got the data. By the way, this is how it looks like from the airplane. It's all deserts, you see. There is no surface expression of subsurface geology or potential mineralization in this area. If you go over, walk over, or fly over, you don't know where is the target. It is 8,000 square kilometers. Now, what we did, we developed in Technoimaging what we call glass earth technology, which provides proprietary data acquisition imaging systems, which make it possible to make transparent the earth. And we call it, it's like metaphorical glass earth. Glass means transparent like glass. And so then we can see what is inside. In this example of this 3D view of subsurface formations produced by the data collected in the plane, example shown here. This is huge model. This model of about, as I say, horizontal size, 8,000 square kilometers, depth 1 kilometer, roughly. This is a magnified area, one of the section. And you can look inside. Really, you can see here, on the left, you can see conductive overburden. Red means more conductive. Then you can see clusters of mineral targets here. You can see alluvium cover. So, and you can actually rotate. You can do whatever you want with this model. You can slice it. You can look from underneath if you wish. You can walk in. There is some technique. You can put glasses and walk inside the model and just walk inside the geology. And this is an example of this model in 3D, how to push so that it's rotated. I try to push, but, oh, okay. So you see, this is 3D model, and I'm very close, 2 minutes will be enough. So this is this Raj model, and again, we slice it in this direction. You can slice it any direction you want. It's 3D image, volume image of the subsurface. This is glass Earth model of 8,000 kilometers of Arabian Shield. Then you can focus on specific area. We selected some area of interest, and then you can see the target. You can look more carefully, and then you can zoom in on specific area and select the target. Then you can pick up the target. And this will be our phase 4. And you can drill. And we did it. And we pick up target from area of 8,000 square kilometers. We selected 3 drill holes, but we drilled just 2, diameter 10 centimeters, and we pick up mineralization. It's mineralization of the same type as Solomon mine, is a mine. It's quartz veins with pyrite, chalcopyrite, and gold there. So we were able to resolve this. So I'm finishing. So the Glaciers project has followed exploration workflow from countrywide selection through drill, hole targeting, and discovery of blind mineralization based on airborne data. The discovery would not have happened without this airborne technology because there is no surface expression of the mineralization. And 300 meters drill hole was sited in the original area of nearly 8,000 square kilometers. And this mineralization of the same type as Mahler the Hub, epithermal gold and silver deposits, located actually not far from our discovery. And there are several other potential deposits in the survey area defined by the Glaciers pilot project. So I think this technology could be very beneficial for Saudi Arabia, not only here, but other places, but specifically here, because it's so challenging to get in this desert area, and cover 8,000 kilometers on foot. It would take, I don't say how long. This project took 1 month. Data acquisition, processing, and interpretation in another month. Thank you very much.
Thank you very much, Michael, for this presentation. Now we're going to go from geophysics to geochemistry with the next presentation from Hassan Al-Arbi. Hassan is Deputy General Manager at Technical Minerals at ALS Arabia, and therefore is going to talk to us about geochemistry testing to support mining industry. All yours, Hassan.
Good afternoon, everybody, and thank you for the organizer, Future Minerals Forum, for the invitation. So we'll be talking about geochemistry testing to support the mining industry. And as a start, we will just talk about geochemistry overview by what's geochemistry, why geochemistry testing is important, and application of geochemistry. So geochemistry is actually a branch of geological science that deal with the chemistry of the rocks and minerals in various igneous, metamorphic, and sedimentary process, and from high to low temperature in various environments. And why geochemistry testing is important is because it provides a background details for a description about the rock origin and evolution. And geochemistry is actually significantly important for geological science, especially for dating rock in various formation and geological process. The application of geochemistry testing. Geochemistry can be applied to exploration for minerals deposit, and it's necessary to understand the fundamental of geochemical prospecting and geochemical dispersion of element depending on the chemical property. The second slide is talking about the main 3 components for geochemistry testing, and that's sample preparation. And sample preparation is actually designed to produce a representative homogenized subsample from the raw samples. And secondly is the decomposition, and that's digestion. And there is various types of digestion and methodology that, like aquaregia, 4-acid digestion, or fusion if necessary. And analytical instrumentation, and there is various types of analytical instrument that are available in the market depending on the element of interest that require. example, XRF, XRD, ICBOS, ICBMS, AES, carbon sulfur analyzer. And over here in the slide, there is pictures showing. So for example, over there at the far right, there is pulverizing machine and crusher machine that's in the sample preparation. There is gold fusion and also 4-acid digestion. And there is the gravimetric gold, ICBOS analysis, and that's glass bead application for XRF analysis. The second slide, we'll be talking about the surfaces overview, so a little bit in details. Starting with the sample prep, and that's including the core surfaces and also the hyperspectral. So usually in the sample preparation, when the sample arrive, they're in different types. So we have drill core, half core, rock, chips, or soil and sediment. And usually they go through a main process in sample preparation, and that's drying, crushing, splitting, pulverizing. There is also specific gravity, bulk density. There is a portable inductive analysis, XRF, can be done once required. There is also core cutting, and there is TerraSpec, and that's core imaging that can be very useful later on to connect it to the data that's actually being processed and reported by geochemistry testing. Secondly, it's the precious metal analysis, and due to the unique property, chemical property for gold, silver, platinum element groups, they actually pose a little bit of a challenge for geochemistry testing. So because they actually often appear in heterogeneously actually in geological materials. And we actually require a little bit of large charge for analytical to actually give you an accurate and representative count of those precious metal in the sample, overall samples. And we are actually using fire assay or screen fire assay, aqua regia, bulk, C9 or leach well, that's a little bit faster, using C9, sodium cyanide, to actually recover precious metals. Secondly, there is generative exploration, first pass and super trace methods. And those is using partial extraction or various super trace ICBMS method. There is also biogeochem, and that's vegetation, usually done in planet, like the leaves or any part of the planet. And you can analyze the minerals actually present in those planets and study the area around it. There is also hydrogeochem, and that's done in the water. And usually in the water stream or the rivers, you can actually directly analyze the water, the minerals actually content in the water. There is isotopes as well. When you have a target exploration and you're trying to define the ore body, the grade and the size, you're actually using one of those digesting approach. So there is an aqua regia, and aqua regia is usually broadly can dissolve all the sulfide, the oxide, the carbonate minerals, and also retain the mercury there and some of the volatile elements as well. And 4-acid digestion is actually quantitatively dissolve nearly all the minerals, but not all of them. Sometimes we actually require a stronger digestion approach, and that's using fusion, either lithium borate or sodium peroxide fusion, especially when the rock contain alumina or silica, and that's a little bit hard with normal digestion approach. And then we have the whole rock, lithogeochem, and carbon and sulfur. So usually in the investigation of geological and the ore form process, it's enhanced and targeted by lithogeochemical, and there is various testing that's used many subsamples that's been done during the geochemical program. That's to actually define the characterization, the full characterization of the rocks type and the trace element that actually associated with it. But it's kind of not stable due to the formation when metamorphism happen. And the carbon and sulfur is actually widely, with the compound, is widely available. It's come with the material, geological materials, and it's available in the ore deposit. And that's actually sometimes it's impacting an issue for the miners, the ore process, and the way how they can actually store the waste of that during mining. So defining the form and the presence of the carbon and sulfur and the compound in their ore help them speed up the ore process and also have a characterization for the waste management there. Over here, this is commonly tested commodity. So the provision analytical testing appropriate for all commercial of minerals commodity that's actually tailored to meet the geologist exploration, the miners, the minerals process engineer, the meteorologist, and those data that extracted are actually utilized for exploration, feasibility, resource planning, minerals control, and concentrated and billion determination, and asset-based count as well, process plant control, and ore characterization and treatment study as well. So commonly there is gold and sulfur, there is copper, zinc, lead, bauxite, iron ore, lithium, uranium and thorium, there is graphite, rare earth, there's cobalt, minerals, sand, and industrial minerals, and other commodity as well. This is just the resource life cycle for the mine. So it's starting with geochemistry testing at the beginning for exploring, and then developing by doing feasibility study, designing, then after that to the mine, actually planning, and then there is a laboratory at the mine site that's actually done geochemistry in daily basis for quality control, to the last step, and that's inspection for trade purposes. So you are welcome to visit our booth if you have any inquiry or questions. Thank you so much for your time. I wish you a lovely day. Thank you.
Thank you very much, Hassan, for this presentation. I appreciate it. Now we're going to be turning to the technology of crushing and screening, and how I can raise safety precaution and protect the environment with Faisal Al-Rashid. Faisal is General Manager of Manufacturing of Saleh Rashid & Son. Please.
Thank you. Good afternoon, everyone. My name is Faisal Al-Rashid. I'm the General Manager of Manufacturing and Spare Parts Division in Saleh Al-Rashid. So usually when we say saving the environment and raising safety precautions, we're always talking about renewable energy, for example, solar power and whatnot. So we took some time to look at it from a crushing and screening perspective, to be able to save on the environment using the crushing and screening that we need to provide the mines with. So, which button is it? Oh. Just a brief overview of our company. Our company has been in the Saudi market for 40 years. We have different sectors, but I'm going to speak today about the mining sector. We've been producing aggregate for 40 years, as I told you, and we're trying to find good and better ways to produce our aggregates. So one way to look at it was looking at the crushing itself as well as screening, and we were on a journey to find a company that can help us reach that, and a company that has the engineering that could help us achieve what we want in terms of saving, using our own crushers as well as screening. So this is the company that we came up with is called Aztec. Some of you might know them as Telsmith, Osborne, or Pioneer, or they have about 6 or 7 companies under them, under their umbrella, and we took their dealership to be able to supply the market as well as supply ourselves with their products. Of course, after seeing their technology to better sustain the environment. So these are some of the models. I'm not going to take some time in it. So we have 2 kinds of cone crushers. We have a K series, that's a Kodiak series, and we have a T series, that's the Titan series. Firstly, I'm going to talk about the Kodiak series. The Kodiak series, as you can see, this is the inside of it. So it's not like the usual ones that we have here, the Siemens one we call them. It's not bushing, it's a radial roller bearing. Now, radial roller bearing are better with softer materials. It is easier to sustain, and it won't be as hard as the bushing. Of course, the usability of it won't be as the bronze one, the bushing one, because there isn't a lot of wearable parts in it, where the bushing, you have to change the bushing every once in a while. A bearing can stay there for 7-10 years without the need to change it. Other thing is that the replaceable bronze threads, usually the cone crushers, the upper assembly has the ring on it. Previously, when the screw gets damaged or anything, you have to change the whole upper mantle. With our technology, you just have to change the bronze threads. I'm going to go deep into it later on with the better photo. Of course, we have the anti-spin for the sustainability as well as the safety. Some other competitors and some other companies use in their cones, use them without the anti-spin system. The anti-spin system stops the crusher from actually spinning without running. So sometimes when you start the crusher, till you get the material to the cone, it spins. And when it spins, the materials come in. When the material comes in, while it's spinning, you're going to have rock coming out of the cone crusher, which will be dangerous for the safety purposes, as well as maintaining the actual liners in the cone. So if you're having it spinning all the time and you're feeding all of a sudden, you're actually destroying the liner. And then now we're going to go to the Titan. The Titan is let's say the more rigid one, the one that you can abuse more than the K series. So what's different about it is that it has a bushing, of course, a bushing like the Simons that you used to use before. So that's what it has. And the anti-spin assembly is there as well. However, the anti-spin assembly is on the top of the cone, not like the K series where it's going to be on the bottom. We have the sealing system with it, and the full top service, the patent hydraulic anti-spin system, as well as the metric design. Of course, a lot of companies use the, it's called metric and the other one, I forgot what's the name of the other one, but it's going to be easy to choose exactly what you want based on our metric designs. So if you're using meters and whatnot, which we are using in Saudi, it's going to be easy to choose what exactly you need. Of course, the direct replacement for the bolt circle pattern, it's for the SBS as well as the Metso HP cones. So this is the lower assembly for the Kodiak. As you can see, it's the bronze seat liners as well as the integral relief valves. One thing Aztec thought that if you have all of these materials coming in, sometimes you might have some metal or something in the cone. So we have a system where it relieves itself so that it won't damage itself. We have that in the Kodiak and the Titan as well. The clearing stroke on the Kodiak is 127. As I told you, you can't abuse it as much as the Titan, so you're going to have a less clearing stroke than the Titan. They both work well. Each one has its own application. So depending on the application of the customer, we can provide him what they want. This is the upper assembly. The bronze liners that I were explaining them is on the third picture. You can see these liners change. So you don't have to change all of the liners itself. So you can just change that easily and quickly. I'm going to skip this. Of course, the Titan liner removal is easy. It's easy to change the eccentric. It's not as hard as the Kodiak as well. In terms of jaws, we have up to 33% kinetic energy. Of course, that means that it's better to use less power. There is the stroke in it. The stroke in it helps it to rotate itself without using a lot of the power of the motor itself, which hence will save the diesel for your production. Just going to go through this really quick. Of course, everything is interchangeable in the jaw and reversible as well. We have the hydraulic cylinder in the bottom so that if you have too much stress, it will release itself so that it won't damage the liners or the jaw itself. We have the high-frequency screen. The high-frequency screen is we have a patent on it, so there isn't a lot of screens like this. I don't even think that there are. What's different about it and what's unique about it is that it will be able to screen microns without using any water, which is better for the energy, for the sustainability of the environment. achieving that without having any blinding in the skin meshes depends on how much the angle is. So if you have more moisture in the material, you will need to jack it even more. So you have to have even a higher degree to have the material going through. Of course, that's without using any single gallon of water. And I don't think you can find that easily, which helps the environment as well. This is the screen from the inside. As you can see, each deck has its own vibrators, unlike the normal screens that we are used to with the shafts, where you have the shafts and the stroke and the weights on the side. Ours has the vibrators where each deck will vibrate by itself and it will give you the microns that you need. This can separate all the way down to 75 microns production. And this is another photo of it. Of course, the deck itself, the holder of the deck itself moves front and back while it's vibrating at the same time. It's vibrating around 4,200 rounds per minute, which gives you the production that you will need without the use of water. This is another photo of it, where it shows it. This is a stationary one. They come in portable, mobile, as well as stationary ones. And this is very big in silica sand. We've got good feedback for the silica sand. And that's my presentation. Thank you very much.
Thank you very much, Faisal. Shukran jazilan. And now I'd like to turn now to Khaled El-Nabout. Khaled will actually talk about 3D laser scanning for mining data capturing. Khaled is General Manager at MENA 3D. Please, Khaled.
Thank you very much. Help me. Just as well. Just one thing. Good afternoon, everyone. Thank you, Cher, for your introduction. Thank you for the organizer to be here. I will go through my slide. Maybe we saw today so many interesting presentations. My presentation is related to 3D measurement, so I'm going to talk about capturing the impossible. We are a German-based company with head office in Stuttgart. We have few offices in the region, and we focus only on 3D measurement. What we do? Mapping the inaccessible. Maybe some of the gentlemen he saw today, he is using the same technology. We have many reference, we will talk about it later, who are using this technology. Additionally, we are presenting this technology to show you and to try it yourself, how you can mapping the inaccessible in area which is not allowed to access. With this same system, we have with organization called Managem. Managem in Morocco, close to Marrakesh, we went 740 meters underground, and we went in dangerous area where is no one allowed to go. We could survey through a hole, and then we could send the drone fully autonomous. No need for a pilot license to fly the drone, because the drone will fly fully autonomous. The drone will go to capture in dangerous area, will go by itself, and it's called SLAM technology. That means simultaneously, the drone is, when capturing the data, is allocating itself. So no need for GPS, no need for communication, because the data is sent straight away to the computer inside the laser sensor of scanner, and giving the command to the drone to allocate this area. I am here, and then this is measured. I can go next and measure the next area and come back. Now, with this data, up to you to use it for sure in mining for your 3D model. And as I said, I'm going to next explain more and more information about it. So, productivity. For rapid scanning and data capture, we are capturing million pounds per second. I'm capturing by walking, or by putting the scanner on a backpack, or putting the scanner on a car, putting the scanner on a drone. And that is making much more easy. Ability to select location, reducing file size on a post. Continuously scanning, that means was a SLAM. We know all the LiDAR technology. We can put it on a tripod. We have also a similar solution where you put it on a tripod. But it's a scanner when you scan and you move the scanner step by step. Here you are scanning by walk, as I said, by movement, and it's a fast access to your data. That means after I come back, I take just my USB, put it on my computer or the sensor, and the data is automatically transferred to a computer. It takes twice the time of data capturing the processing of the data. And that's it. Cost saving, for sure, it saves a lot of time. Women and manpower on the site to capture, low operation cost, you don't need to be an expert, and for sure, it's a upgradable hardware of platform. You can use it also for only mapping, or you can use it, as I said, on a car or on a full autonomous. This is here at KAICC Personal Away. It's a similar, this is even in Morocco, a similar case we had where you could really dangerously is not allowed to access. The drone could itself go and measure the area and go again in a hole over 20 meters, measure and come back. It's already proved, as I said, Ma'aden, our main sponsor here, is already using this technology, so we are not talking about future. It's already in use, it's already in Saudi Arabia. Manajim and many other sites are using this technology. So it's nothing new, but it's developing better and better. This is also a case which I would like to talk, because we have always a request, do you have something to find underground for gold detection? This is a KAICC project. We are using with this case the first drone in the world. What that means? This drone, what you see here, it was found 30 years ago, and it was the first drone which had been used for filmmaking. It's won already an Emmy Award and 2 Oscars. The James Bond Skyfall, it was being used, the same drone, and we are working with our partners to use different sensors on it. So you can mount different laser scanners. You don't need it only for filming, because you could use it in this case for gold detection, as you see. This is a real KAICC project. It's going on since more than 4 years. And with magnometers, you can detect underground and you can find what material. For sure, we are not the expert. You are the experts here. You are the geologists, so you know to read the materials, what is under. But you can see the speed and you can see the advantage of it, even for underwater. You could also use it. We have two. We have with turbine, and we have also electric, which is electric can fly 1 hour and carry 10 kilo, whereas with the turbine can fly can carry 30 kilo and fly 3 hours, and can go up to 100 kilometers. And we'd like always to show a real case, real examples, because then it can be. So this is all the information about this project. Overland and oversea, as we just mentioned. It was a 20-day mission, 132 flights. So next one, we work with the Austrian partners, Regal. They have the longest distance laser. It's a time of flight. We have different types of lasers. There's a phase shift and time flight. So you need a time flight when you are measuring here. We can go range even up to 6 kilometers with a new laser. Here is about 2,500 meters. Accuracy down to 1 millimeters. And you can imagine if you want to survey this area, it's impossible. With a traditional GPS or traditional equipment, we know it will take years, not weeks and not months, years to measure such area. And with a laser where we can reach up to 6 kilometers, it's done in a day. And you need to monitor, you need for sure volume calculation, you need to check. Often, again, it has a GPS here, so you have your exact location. It's work with SIM data. That means I have a SIM card where I can, with my SIM card, transferring my data on site immediately to my colleague in the office, and he receives the data immediately. The same LiDAR we are also using at the moment for surveying complete Qatar with the aircraft. You can mount also the same type of laser, an aircraft. You can fly over complete country and measure and survey complete country. That's a model, as you can see. This is a point cloud. We have also some bathymetric and aerial system where you can mount an echosonder and a traditional drone, because we had already, this was edited in the last minute because some colleagues said, can I measure a survey under bathymetric? Is there now a lot of question going on and request for it? Yes, there are some sensors where you can mount it simply. It's very simple. It's, as you see, 4 or 5 pieces of tools and software mounted on DJI drone, which all of us know. It's available in the market, and you can survey it. For sure, the most important is the software, where you can get out of this data from an expander and get your model. We have a few references, just quick selection to show you. We are since 10 years in the region here, and we work with a lot of government and research organization. Additionally to Germany, we work also, as I said, universities. We work in Germany with the German Space Agency. In service, there are a few reference companies who are using our solution in the region, who they offer the service for companies, and manufacturing also, we have some reference. I hope I was on time. Thank you very much.
Shukran Khaled for this presentation. And after drones and Hollywood making movies, we're going to have some fun with gaming technology now with Thomas Rowe. Thomas is project manager and XR technology advocate at Sentient. Thank you very much, Thomas.
Thank you so much. Good afternoon, ladies and gentlemen. So, 11 years ago, a tier 1 mining company came to us after a serious health and safety accident occurred on one of their sites. After looking at this, what happened is someone was doing some maintenance on a piece of equipment, and they were using an old work procedure document. So we wanted to find out and deep dive what exactly went wrong here, what led to that old document being used. And we found a couple of things. The first thing being that there were too many sources of truth. So relating to this one asset, you had all these different platforms that had documents and information relating to that one thing. The other thing being, each of these platforms had their own authentication hurdles. So they had authentication apps and passwords that users needed to remember and log into each of these systems before they reached those documents. A combination of these things ultimately led to users logging into those systems once, downloading the file, and then storing it onto their desktop. And the issue with that is they would have no idea if that document has been updated in the future. So we thought, what can we do to prevent this happening in the future? We need to collate all these sources of documentation and just create one kind of platform. So we needed to make it easier to work the right way than for people to do the wrong thing and download these files to their desktop. If we did collate all this information into one spot, it would mean that people would only need to log in to one platform. That would get rid of the authentication hurdles. But if we just got all these files and put them in one place, it would mean that we'd have thousands of documents and thousands of folders, and we'd have issues with that as well. So we needed it to be organized in a way that would allow for fast access. So we were doing a lot of 3D animations and work at the time, and we thought, let's get all this information and put it into a 3D representation of that mine site. We'll create a digital twin. So we started planning this digital twin, and then that's when we started to see some challenges arise. The first thing being the size of these things. So mines are massive environments, and the engineering models we had millions of CAD nodes. So these things are very detailed. So you've got a really detailed model, and then you're combining that just with your average company laptop, something that's designed to browse the internet, send emails, maybe a bit of YouTube as well. So how can we get something so big to work on a really average laptop? If you combine these two things with really poor internet connections that mine sites are notorious for, and also wanting to provide really good value for our customers and a fast return on investment, how could we do this? We were kind of stumped. And then we had a light bulb moment. So our founder, Doug, was sitting down and playing some video games with his son. I think it was Call of Duty or something similar. And Doug realized that his son was able to navigate through these really complex environments with ease, and the computer he was using had no trouble at all in doing so. So we thought, why can't we use the same programs and same technology used to create these video games and apply that to our digital twin? So that's what we did. And we've called it INDIE. It's our industrial digital interface. So by leveraging off a program called Unity, which is used to create games like Pokemon Go and Super Mario Run, we were able to take its best features and combine them with some clever development to create a digital twin that solved all of those challenges that we were facing. The really good thing about leveraging off Unity as well is that when a new feature does arise, like compatibility with VR, for example, we're able to adopt that into our digital twin and pass that on to our customers really quickly. So what better way to explain it than to show you? So we've got a video here of someone entering in an asset code and then getting flown directly to that asset. So you can either find things this way, or you can navigate through as you would in a standard video game. This next video is another feature we've developed called cards. So you're getting a really clear and quick indication of how everything on the site is going and what the health of your assets are. And this third video is just showing how we can tie multiple data sources together and tie them to that asset. So we've got some live data being shown here, but we can tie things like CCTV, work instruction documents, and show also historic values of information. So going back to that first case study where they had the incident on site, we've seen that the company that has adopted, that particular company, has adopted Indy into all their sites across Australia, and they've estimated that there's cost savings of over $3 million per year, that's Australian as well, just through improved efficiencies. And most importantly, that software is saving lives by providing the right documentation to people at the right time. That's all I have time for today. I would love to answer more of your any questions that you have. I'll be at the Sentient booth, and it'd be great to connect as well. Thank you so much for your time. Cheers.
Thank you, Thomas, for this. Very much appreciated. Now I'd like to welcome on stage Tanya Nasir from 3ME Technology. She's Business Development Manager. She will talk to us about mining electrification. Thank you, Tanya, for being with us.
Thank you. How do I go next? Okay, awesome. Assalamu alaikum. Good afternoon, everyone, today. I'm going to be talking about mining electrification. I'll try to keep this one short and sweet. Okay, so let's start by who are we, 3ME Technology. A while back, around 2014, a miner out in a farm somewhere near Sydney was not too happy with the fuel prices. So they decided to go and electrify a Mazda 2 with a hybrid. They continued to electrify smaller projects, mostly commercial on-road, and then eventually striked the attention of two mine personnel that saw that there is an immediate need for electrification in the underground mining environment in Australia. Why was that? We'll walk through that today. And basically, ever since that day up until now, it's been constant development to ensure that our mines, our construction, tunnels, and all of that has been electrified by 3ME Technology in Australia. Our product development has been driven by our target markets being mining, military, and marine, and that's where the name 3ME Technology comes from. The main drivers in the Australian market is similar to all drivers around the world and the pressures that we're experiencing. It's around decarbonisation, improved working condition for the underground mining environment from a safety point of view. If you were to put an EV underground, you're eliminating diesel particulate matter, which then allows us to breathe better working conditions, elimination of noise and heat, which means that you will need less ventilation cost underground, which then will lower your energy consumption and cost overall in the mine. And of course, improving the environmental impact, which is an important point. Now, the electric mine. What I've got there on the screen is a concept electric mine. The 4 different topics is battery electric vehicles, so the actual fleet operating in the mine. The other concept is power management. So load management, what does that actually mean when you electrify a fleet? We need to start thinking about an ecosystem. You would put a fleet of electric vehicles in a mine. You will need to manage the load, the grid, buffering, ensuring that all your energy is coming through at the same time. There's no peaks or loads anywhere on the system. Number 3, you've got interoperability. What that means is that you need to actually make sure that the protocols are working together, communicating and connecting throughout. And of course, lastly, it's the green power source. You can put a fleet of electric vehicles and try to decarbonize and reduce the carbon emission. However, if you're still charging it from a diesel gen, it's still not carbon neutral quite yet. I guess the main focus, given that we are a battery company and a battery manufacturing company, I'll be talking about the challenges that we experience from a battery electric vehicle point of view. We deal with lithium-ion batteries, mainly NMC chemistry, so that's nickel, magnesium, cobalt. The idea there is that we design, manufacture, assemble, test, to do all of that in-house, as well as the systems integration piece. And that's where the safety comes from. Some of the challenges that we've encountered would be around safety, scalability, and integration. What does that actually mean? The battery needs to be safe if we're going to operate it in the mines, given that it's an explosive atmosphere in most cases. And then our battery system has a racking system, as you can see there, that allows it to be scalable. The battery management system and the thermal runaway protection system and compliant hardware all comes in within the one pack. The racking system allows us to have better visual and control over the cells in there. So each rack has 2 cells upon each side, and what that allows us to do is have direct access to the cells to be able to isolate them in an event of a pressure or thermal runaway. Of course, this battery system meets the stringentest industry certifications and compliant. We've already got vehicles underground in Australia that have been electrified, and they meet those compliant standards there. And of course, the importance is that it needs to be a network battery as part of the full system integration. Recycling challenges. Now, these batteries that we're talking about are massive. They're not your small batteries. The average battery that we've been producing weighs about 1.7 tons, and it's lithium-ion, so it's full of chemicals and other things that need recycling. At the moment, there is a common trend in battery recycling, which is the redeployment. But what you need to do before you redeploy is you need to maximize your first life cycle. When the battery reaches 80% capacity after mobile use, it is no longer fit for mobile applications, and that's because it might not be able to sustain the load throughout the system. Therefore, what we will do is we'll take that out and then we will reassess and recertify. Given that it's a racking system, it is a super modular and sustainable design. The way we've designed it allows us to separate the chemicals or the cell itself from the mechanical structure. So you could take those blades out of the battery and re-rack it in a static storage solution system or a grid control and regulation system. And that's been a common trend within battery providers and suppliers. Now, of course, once it reaches the end of life at the second state, you will need to recycle it. Now, integration challenges. This one is actually a big topic. I've put in, I guess, the 4 different integration challenges that we've encountered, but today I'll mostly be covering battery chemistry and battery size fit for applications. The battery that we've designed is chemistry agnostic from a lithium-ion point of view. So you can go with nickel, magnesium, cobalt, or you can go with lithium titanate or LFP. And basically, the choice of such chemistries will actually be based on the application for the end user. All chemistries are susceptible to fire. They all have hazards and risks, but they all can be managed differently, and they all fit different applications in that instance. And so in order for us to understand what battery we're actually going to be integrating into OEM vehicles, we're going to need to adapt a full system solution. What that entails is a duty cycle analysis, which then is about understanding the operational profile of your machine. Doesn't matter what machine it is, it could be a dump truck, it could be a front loader, an integrated tool carrier. They all will have different operational duty cycles, and that is key to understand in order for you to be able to integrate it into a vehicle. That will guide the size of the battery and the chemistry. It's also important to not sacrifice the payload. With a lot of the conversions, once you've taken out the transmission and you've put in an electric motor that is much lighter normally, and therefore you're actually underweight or slightly on par with the weight there. The next stage is prototyping and systems integration. You need to be able to prototype this in an efficient manner with all the right components on vehicle, and that's why we adapt a systems integration approach there. And then we also do the control software and hardware capability in-house. What that allows us to do is actually ensure that the safety is cohesive across all, that the power is being distributed correctly, and that the battery is being managed correctly. That then flows on to charging solutions. We have, of course, assessed charging solutions off-board and on-board. We found that it's essential to have an on-board charger for your equipment, and that's because of opportunistic charging. What that means is that if you're underground in a mine or in an open pit and you're about to do a job and you're idling outside your vehicle and you have your vehicle on, you can actually keep it charged through opportunistic charging with your on-board charger, and then you could switch that off and move on to your next task. That allows you to buffer your charging. And finally, remote monitoring and asset management for the battery. It's really important to manage the batteries in real life time. It's important for you to understand what it's actually doing in that moment of time. And what that links with is your battery management system. The battery management system will be able to tell you if it's pressurized, if there's temperature on it, and you'll be able to isolate it. Therefore, remote monitoring is the last step that closes the loop together. That's kind of all I had. I wanted to keep it short, and if you have any questions, I'm happy to take them. I'm in the MindTech zone. So yeah, thank you.
Shukran jazilan, Tanya. And now we're actually going to get that last tech talk before a couple of very interesting panels. So I'd like to call here on stage Subendu Roy. Subendu is actually from KAICC Measurement, Regional Sales Director, India, Middle East, and SEA. Subendu is actually going to talk to us about fiber optic sensing and how they use in conveyor health.
So how do we use this one? Okay. Yeah, good afternoon, everybody. I will start with a short video and then maybe some applications.
Since 1988, KAICC Measurement has specialized in the mining industry, providing reliable and continuous level measurement on conveyor belts, storage silos, thickeners, crushers, and block chute detection, with the ability to send real-time data to the cloud, computer, control room, or even a smartphone. KAICC has a long history of success in some of the harshest environments and applications, with manufacturing locations in Australia and in the USA. We're committed to providing innovative technologies, and we do this by listening to our customers' feedback. This means we invest heavily into R&D. Some of the technologies we develop for the mining industry are below. First, fiber optic technologies for conveyor health and predictive maintenance. They're used for pipeline leak detection, perimeter and security monitoring, hotspot high voltage cable monitoring, and real-time monitoring of tailings dam loading. The Praetorian fiber optic sensing for conveyor idler monitoring has been used for predictive maintenance, which eliminates unscheduled downtime and increases productivity. KAICC's fiber optic sensing can also act as fire prevention on conveyors by using our dual temperature and vibration system. KAICC's microwave technology has had several innovative design changes over the years based on customer, application, and site requirements. Circular polarized microwave design was incorporated into the latest design to overcome the influences of buildup on sensor phase and provide reliable block chute detection, even with dust suppression sprays. The Gladiator microwave is now being used for preventative maintenance, since it can notify operators of abnormal conditions. KAICC's acoustic wave technology has been used in the mining industry for over 30 years for applications such as ROM bin level, crusher level, stockpiles, truck positioning, and many more applications, with the ability to measure even in dusty, dust suppression environments because of the self-cleaning properties and low frequency and long distance measurement. It's proven to be a reliable technology. And KAICC Sultan acoustic wave now has a power over Ethernet option. KAICC sonar thickener control technology is able to measure both high density sludge level, but also the settling level interface. This allows operators to control underflow density, as well as the settling rate. KAICC has developed the flotation cell pulp and froth level measurement technology. It was important to develop a technology that provides accurate and reliable measurement without the problems associated with buildup on probes or on floats. Our guided wave radar technology has been developed for solids, liquids, slurry, and liquid interface applications in some of the toughest environments. Hawk's guided radar also has the option of power over Ethernet. Through-air radar technology has a small beam angle, very good filtering to eliminate false measurements. Ultrasonic non-contacting level technology is primarily used in liquid applications, tanks up to 12 meters, with robust signal processing for the industrial environments. Hawk's level switch incorporate technologies such as admittance, vibration, and conductivity for tank and bin point level. This is for high and low level detection. Hawk's developed the new Hawkeye 365 remote monitoring system that allows users to access plant information locally or via a cloud portal. This system is unique and can be used for almost any measurement device. Our expertise is providing reliable measurement systems, and some of the applications are listed below. Customers in the mining industry need a reliable partner they can trust to perform extremely difficult measurements and systems that are designed with this market in mind. Hawk Measurement has over 30 years in the market, has a proven track record, and time-tested products. We lead the industry in product and technology development. We're actively looking to solve problems and provide solutions to make our customers' investment better, protected, and profitable. I want to thank you for your time.
Thank you, everybody, for your patience. And just before I wind up, few more applications, because I prefer talking on the applications than talking about the technology, how we do it. I will just give some references of the applications that will make more sense. Like the mining industry, one of the major problems that we have seen across the globe has been the collapse, especially when we are talking about open cast mines. So you have open cast mines which tends to have slope stability problems. We use the same fiber optic technology to address that issue of slope stability. Then the other application that we have been doing is for the underground mines, for the roof stability. Again, we are looking for the strain instead of looking for any ground movement. So we can predict a failure even before it starts to move. There has been technologies on the market using Dopplers and other technologies which basically looks for the ground movement. But we basically are trying to catch the event before it happens. So most of the product that we talk about are capable of doing a predictive maintenance also. So anything on specific applications that you intend to discuss, I'll be available for tomorrow also. Thank you, everybody.
Thank you very much for this. Now, this completes the round of 10 different TED Talks that we had on the schedule, and we're going to actually cap this session with two very interesting panels. On the first panel, we're actually going to be talking about innovating and sophisticated technology. Can this look like, what can this look like in the region? Sorry, closing the gap between concepts and capabilities. I'd like to actually here welcome on stage the moderator, Peter Bryant. Peter is board chair, development partner institute in Clario. And he has a very interesting panel composed of Tadeu Camero, chairman and chief executive officer at Boston Metals. Please, Tadeu, if you can join us. Jim Kiravella, that was actually with us earlier, CEO of Offworld. Aus Atawil from Aramco. And finally, Michael Zdanov, chairman and CEO of Techno Medging, and Naushad Ansari, country head Saudi Arabia at SR Steel. Please take it away from me, Peter.
Thank you, mate. Appreciate it. I'm good. Thank you. I'll just let these illustrious panelists settle in for a few minutes. Thank you. Welcome. Always difficult at the end of the day because we're the only thing standing between dinner, right? Almost. So what we're going to talk about today is kind of some innovative technologies, but the context in which we want to talk about is how the minerals sector needs to support the just transition to a cleaner energy future. And I think it's a responsibility we have as a sector to deliver minerals that are affordable, adequate in quantity and a secure supply, but most importantly, that is responsibly extracted and processed. So to be able to do that and fulfill that obligation, we need to be able to overcome some pretty intractable challenges that the mining industry faces, right up and down the value chain, even reaching into the downstream activities which minerals contribute. And what I want to do is I'll just summarize a little bit of what I see as some of those challenges, and then we'll go around the panelists to kind of get a point of view on the areas that they have expertise and open it up for a discussion. So obviously we know about the growing energy and water intensity that mining's taking. There's a statistic that says 1 pound of copper takes 16 times more energy and 3 times more water to produce today than it did 35 years ago. And it's only getting worse, it's not getting better. Declining grades in very many minerals mean that increased costs, capex, opex, declining efficiency in mines, and exponential increases in waste, especially tailing dams. Poor resource characterization is a major problem, all the way from exploration, all the way through to the processing plants. Our exploration rates are pretty poor, both in terms of our ability to identify, so we have a very poor hit rate there. Our ability to get from the resource to first production can take up to 20 years for permitting and construction. And then how do we access ultra-deep resources, deeper than 3 kilometers? And then all these small resources that are uneconomic and technically unfeasible. So it's quite a list, and there are more. But I think we really need to kind of be able to tackle those. And then there's obviously non-tech headwinds. But what I'd like to do is first actually go to Michael, because I think at the hub of all this is how do we characterize the resource? Because that affects everything, through mine operations, weight, everything. And the industry really has wrestled for decades with how do we get an accurate characterization of the resource. So Michael, maybe if you could just talk to us a little bit about how you think about that in your organization and see where we go from there. Thank you.
Okay, thank you for this question. And I will try to answer this question as a geophysicist, because we use geophysics to make discovery, to identify potential target, potential deposits. But for mining companies, the question is not if you discover deposit, but if it is economic or not economic. What are reserves there? And unfortunately, until recently, actually until now, geophysics or geology cannot answer this question before drilling. You have to drill, find the rock samples, analyze it in the lab, petrophysical lab, electronic microscope, determine the concentration of useful metals, and then you can estimate the reserves. It would be wonderful if you can answer the same question using remote sensing, using geophysics, without drilling, because then it will be much more economical and safe and environmentally friendly. And the question is it possible in principle? And what I want to say just in a few words, because of course it's a long story, that I believe it's possible. And why it's possible? Because what we determine through remote sensing, we actually determine bulk physical properties of the rocks. We cannot determine specific formation, specific structure of the rock samples. We cannot determine what kind of minerals are there remotely. That's why we need to drill. However, there is such mathematical and physical field like effective medium theory. What effective medium theory tells us? It tells us how the bulk physical, integrated physical properties related to the internal structure of the rocks. It even tells you how effective parameters analytically connected to the different inclusions of gold, copper, quartz, other minerals. Okay, so we can find effective parameters remotely. But then if we use effective medium theory, we can make the next link from effective parameters to microscopic structure of the rocks. And we are working now on this next step, and we have some, I think, understanding how to do it. It's unfortunately not commercially available yet, but there is at least a way to go using physics, mathematics, together with geology and mineralogy, and connect the dots. So you can go, and then at the end, you will be able remotely to determine what is the percentage of the gold, what's the percentage of the copper in the deposit. And then before drilling, you can say, is economic or not. If it's not economic, don't drill it. So you save a lot of money, save an environment. So this is, I think, the future to go use advances of physics, mathematics, and geophysical methods to try to avoid over-drilling.
Michael, thank you. I think, holy grail, if we can get rid of drilling and exploration, I think that'll help a lot. So, Jim, that's a nice lead into you and Offworld, and you're one of the leaders in kind of robotic mining, and Offworld is a spin-out from the Jet Propulsion Labs in the US. So, obviously we've got a challenge within the mining industry. Scale has become an Achilles heel. So we've gone to 300-400-ton trucks. So a bit like the oil industry, we've kind of got, we can't access things economically. So the promise of small robots doing things like ant colonies is really fascinating. So Can you talk about that a little bit for us?
Certainly. Thanks, Peter. Good afternoon, everyone. So the last 100 years of mining have given us a little bit of an easy ride as we've had surface pit mines, open pit mines, easily accessible with reasonable grade. The future, there's no more open pit mines at scale to discover if we're going to comply with the new era of environmental compliance. Smaller, richer ore bodies are deeper underground than they've ever been. If we're going to achieve the requirements of multiple times the mineral extraction to meet the goals of decarbonization and renewable energy, we're going to have to go many, many kilometers down into smaller, higher grade ore bodies. Offworld has developed a swarming system of robotic species built on a common operating system and platform that are intelligent, autonomous, and collaborative, use energy tools instead of physical tools such as directed beam microwave and electropulse in a modular, intelligent configuration. Our robot species can then explore, extract, process, handle the materials, and move that material underground. So the key objective of the maturation of our swarm robotic mining technology is to liberate mineral as few centimeters as possible from the original rock face underground, and to move waste rock as few meters as possible from that, so that before the end of the decade, our robots will be just treasure bots bringing mineral ingots, excuse me, mineral ingots out of the ore body. And that is the future of mining, which will be massive decarbonization, 2 orders of magnitude reduction in energy and cost, and a reconfiguration of what it means to do ecological mining.
Jim, thank you. And also the promise there is potentially much faster time to resource access to first production. So because we don't have these massive developments.
Months instead of years.
So and the one thing I like about this is the inspiration from nature. So it's kind of so I think we should always look to nature does things very efficiently, and sometimes we ignore that. To do Boston Metals, very exciting. We, particularly for iron ore miners and coking coal, is steel, scope 3, really, really important. Probably the one area in the mining industry they really do need to pay attention. You guys are leading in this kind of green steel area, so really interested to, what's Boston Metals doing and what are your thoughts in this area?
Of course, thank you. Thank you very much to the organizers for inviting me for this super important conference. We at Boston Metal are decarbonizing steel manufacturing. Well, scope 3 is something very important for every company, including miners. You don't, by taking care of scope 1 and scope 2, if you think of if everybody takes care of scope 1 and scope 2, everything is solved. No, that's not true. Scope 3 Last time I checked, the transportation of the employees in an organization is part of Scope 3. So, every company needs to understand the whole equation, and there are several reasons why you do that. You reduce cost, you understand the whole supply chain. So it's extremely important, and you find value. At the end of the day, Scope 3 means value. And in our case, we developed this technology to eliminate coal from steel manufacturing completely. Okay. So you add iron ore in a furnace, which you call a cell, because it's an electrolytic process, and it doesn't, any iron ore, doesn't have to be premium iron ore. And you pass electricity, you split the bonds, get your iron accumulated in the bottom in the liquid form, and emit oxygen as a byproduct. Okay. So that's the main game. But we are also deploying, and we are at the pilot stage at this time. The whole steel industry is very interested in what we are doing because it's the only technology that can scale up to millions and millions of tons. I mean, steel is 2 billion tons per year, multi-trillion-dollar business. Yeah. Now, the same technology we are deploying now in Brazil with our first operation to extract value from slags. So mineral waste that has value in it and represents negative costs, liabilities in balance sheets of companies, can be used as feedstock in our process to recover value. We have an operation starting with slags from tin extraction, and we will start by producing tin, ferroniobium, and ferrotantalum using this technology. But it can be used for every high value-added product. So manganese is the case, vanadium, cobalt, moly, any waste, any tailings, and the next step would be transforming tailing dams into mines.
Yeah. So often they have higher grades than the actual
you don't
mine.
need higher grades. So at any minute, the maximum amount of iron oxide you have in the furnace is less than 10%. So since the other components of the electrolyte are simple oxide, which by the way are the impurities in the iron ore, you can use anything that is in a tailing dam. So it's really revolutionary. One other aspect that's very important that is associated with Scope 3. If you have everything you need is electricity. You don't need water, you don't need acid, you don't need anything. It's iron ore in, electricity, you get your molten iron. If you have electricity at a mine, you ship a metallic instead of shipping iron ore. So that's 40% less weight that you are shipping. That helps a lot.
No, that's awesome.
It's really revolutionary.
Yeah, there's not much not to like about what you're doing, so it's very exciting. I was switching to you. You work with the largest national oil company on the planet, Aramco, which is also known as one of the great collaborator, great innovator across the industry globally. And you're working in one of the centers of excellence. So what can we learn from Aramco and what the oil industry does, and both how we approach innovation, but also specific technologies, perhaps?
Very well. Thanks for having me today. And first of all, obviously, geoscientists gravitate to each other.
Yeah, I noticed you guys sit together. Was that by accident or design?
No, it was natural, organic.
Eutectic bonding. Then.
That's correct. Bonding, we like engineers too. I'd like to take you on a quick journey and ask the audience maybe to work with me in using the most important, most powerful piece of technology, our minds. And with our mind's eyes, if we were to draw an XY plot with a 2x2, and think of the oil industry and the oil and gas industry and the mining industry on the x-axis, and think of the operating companies and the service companies on the y-axis. Just think of that as a 2x2. And now let's start to fill in these boxes, the technologies that were developed, past, present, and future. Well, past and present. And if I start with the past, and let's go with this landscape in the third dimension of time and start with the past. I'm trying to build the case that there are no boundaries between the industries, and as follows. If you think that today we don't have rotary drilling, where would we be today in either industry? And the technologies that were researched and developed, like logging in the oil industry, the technologies that were really expanding in the mining industry, like coring. And then you think about the discipline of petrophysics that was born out of the oil industry. You could argue Gus Archie was the first to develop some of the laws of petrophysics. Seismic, I mean, the solid earth physicists were the first to use it, and seismologists. But eventually, seismic became a standard in both industries. Now, and I can go on like that, but at least each one in this room can list a number of technologies that were researched and developed by service companies in either industry or by operating companies. When it came to deployment and moving across, well, there's another important example. Geostatistics is a science, and geological modeling as a technology was born in the mining industry and transferred to the oil industry. Okay. All of this happened not exactly organically. It happened mostly when the deployment came, it came through the service companies. And if you think about that is the past, how are we doing in the present? It's amazing. Just today, in my first mining conference to attend, I've learned so much. Just now, what Michael was describing could be classified as rock physics, basically, which is what we use. How do we pull petrophysical properties from seismic on both the rocks and the fluids, in this case, the rocks and the minerals? It's the same thing. We do fluid detection from seismic. We try to find gas before we drill and then test it, and so on. So the technologies in the present, from the past now going into the present, have been accelerated with the compute power and you could argue the soft side of things, of the technology, software, artificial intelligence, and so on. And so much is exploding now in both industries. Now, where we're going in the future is going to be very interesting because we can't rely only on the service companies to do it by goodwill or by business sense. We have to do more than that. And I think I was amazed this morning in the plenary sessions when you hear His Royal Highness and Their Excellencies, the ministers that spoke this morning, Prince Abdulaziz, Minister Al-Khuraif, and Minister Al-Faleh. Everybody was pointing out the expansion that's happening in Riyadh, especially under the context of Saudi Arabia 2030. Yep. And the regulation that's been put in place. I mean, I don't have to repeat what was said. So it looks to me that we already have all the elements from the past going into the present. We have all the players, and now we have the place where it can all come together and grow from there into something bigger. I think even in your comments, Peter, in your opening statements before the conference, it's conferences like these when both industries may be able to come together and share the knowledge on the technical aspects and on the technology aspects. And it's amazing if we don't do that, it's just going to take longer. It's going to happen, but it's going to take longer. Yeah. So this is sorry for digressing a little bit.
No, that's an important point.
But this is my lay of the land as a landscape of where the technology exists. Research, development, deployment, and thinking about it past, present, and future. Yep. I'm seeing a beautiful future coming in that sense.
Lovely. We like a beautiful future, and I think it's interesting to think this is probably the only mining conference where we have a reasonably good presence of the oil industry, because every other mining conference, and you often get this, well, we're different, so we don't need to listen to them. So, but we need to break down those barriers, and we do that by talking to each other.
If I may say that the presence of His Royal Highness Prince Abdulaziz in this conference is sending a strong message, and presence of His Excellency, Mr. Khalid Al-Falih, is also another strong message about the opportunities for business in the future.
Together, yeah, no, I agree, yeah. Nashad, is that a good pronunciation? I don't want to butcher your name, so I've been known to butcher names before. Nashad, ESSA, fantastic organization in India, doing some really interesting constructions and projects. In particular, I believe there's a talk about the new flat steel green plant, but I think in the context of taking advantage of local factors, I think that's really interesting, and building this in a kind of economically sustainable manner. But so I think often we forget, we just think about the technicalities of projects and don't look at local factors, communities, environment, whatever it is. So do you want to talk a little about what you guys are doing and how you think about it?
Absolutely. Thank you, Peter. That you give me a chance to kind of talk about the challenges that we are going through at the moment. So no, that's really what SR at the moment is doing is that we are wanting to build a large integrated steel plant within the country. And before I talk about the issues which are there related to that, the challenges, maybe I can give you a little bit of background, so that should be useful. So we all agree that Saudi Arabia is changing very rapidly, and one of the major drivers for that change is the great vision that the country has for the industrialization. So the country wants to produce, let's say, all the upstream kind of grades which are there, which are required for automobile industry, for the food packaging, for the electrical steel, and so on. The country really wants to get into all that, all at the same time. So, so when we were discussing this with the Ministry of Industry and more specifically with the NIDC, which is the part of the Ministry of Industry, then there are some challenge to us. They said that you build this plant, which is going to be one of the world's best plant. This is what the intention is. But at the same time, it also needs to meet the current needs of the country as well as the future potential needs which are already on the anvil, so to speak. There were three things which are really coming out of that. One is that if you look at the total demand of it, obviously if you want to build a plant which is viable economically and things like that, you look at the demand. So if you look at the demand, then the total volume of the demand was not so much. And each of these packages were also not that much. I mean, if you look at the world picture, so to speak. But at the same time, the width of this entire requirement, so to speak, we wanted to produce 0.8 millimeter thick steel to 25 millimeter thick steel. We wanted to produce the widest steel, so to the narrowest steel, and we wanted to produce the highest grade steel which is required for food packaging as well as for the let's say automobile industry and so on, just to give some examples. There was till about a year back, there was not a single process which could have met this requirement. And then if somebody wants to meet this requirement, then the only way was to put multiple units. And if you put multiple units which already have the larger capacity and you're not utilizing it, then it's not viable at all. So this challenge was given to us, and on top of it, obviously, the other issue is that the plant needs to be built in a so-called the green plant. It needs to be built as a green plant. So these were the things which are there. So we took this challenge and we had very detailed discussions. We already have our own experts which are there, and the discussions took place with the best of the technology suppliers in the world, which are, there are a couple of European suppliers with whom we had extensive discussions for about 6-7 months. Together with them, we started looking at what are possible options. Fortunately, there was one particular plant which was built in the US commissioned only a few months back, and that has certain capacity, but it still did not have sufficient capacity to do that. So, for example, just to give you an idea, a conventional hot strip mill can produce, let us say, from 1.5 millimeter to up to one or what other grades, but it cannot make ultra thin grade steel. And if you want to make ultra thin steel, then you have to make, put up another plant. But this particular plant, which we ultimately have embarked upon, the kind of design that is there, that's something which has the capability to meet the requirement of green steel. It has the possibility to meet the entire product mix range which is there. And overall, it still has the volume capacity which makes it viable. So this was one major issue which was there. And if you want to, I can tell you a little bit more detail about the technical part of it. So if you look at the conventional hot strip mill and slab caster, you actually cast something like 250 millimeter slab, and then you heat it up in a furnace, then you take it to a rolling mill. So these stages, there is substantial amount of energy which is required, because what you really want to do is from 250 millimeter, you want to convert it into, let's say, 1 millimeter kind of thing. So the energy which is required is huge. In the world, there was also a process which was called the thin slab casting and rolling. I hope there is time to kind of...
because we've got to go round. So
I'll just very quickly
we've got some more questions.
Very quickly get to that. So the point which I'm really saying is, that we were able to look at this challenge. At the same time, one of the issue was in terms of the green steel. So if you want to talk about the green steel in the next round, I can do that. Otherwise, that may be an idea.
No, that's fine. No, thank you. That's very interesting. And maybe you guys should speak to each other, yeah? So actually, one of the things I want to touch on is, and it's a theme within the conference and within the ministerial roundtable yesterday, is, the mining industry is very famous or infamous for piloting technologies, but somehow they never ever find their way into operational mines. They don't scale, etc. So we end up with all this, I call it stranded innovation. So what do you guys think? What do you want to see as technology innovators from the mining industries to see that the really interesting technologies, and obviously not just mining, how do we get these things out and scaled?
That's very straightforward and very simple.
Thank you, Jim. I knew you would leap out of the blocks on this one.
So since you insist,
I insist you answer first. You go.
I'll have a go at answering that. I think the challenge is that there are two levels when we're addressing the innovative technology curve of 2023. The first level is where the technology is at right now, especially at the frontier of what we need to go forward with. The second level is the promise of the technology that we expect to achieve the economic goals and the environmental goals that we're projecting. The challenge that we all face as a community, both in technologists, miners, other sector partners, is that the communication about these two levels is effectively a mismanagement of expectation. And the gap between that expectation is a failure of imagination and a failure to communicate the possibilities of what's coming and to instill a clear pathway of expectation so the capitalization of that development of that innovation is secured, it's ready to go through what is called traditionally a valley of death in innovation technology terms. And but I think it's very, very straightforward. Excuse me. As long as we manage the incremental steps and the milestones of technology development so that we're always bringing value out periodically, but managing that in a long-term or medium-term pathway. And I say the medium-term pathway is a 5-year, 8-year pathway. And that's the way to do it, is to take the whole vision in one go, communicate that, but not to forget to communicate the incremental technology development steps.
No, that's interesting. Oz, I'll pick on you. And sorry, anybody else on the mining adoption? I do want to pick on Oz and say, the oil industry does not have this same problem at the scale that we have in the mining industry. So just think on that one. Anybody else on the mining sector, what you would see different?
Well, I think this it is a problem as you described. But the thing is, when you have a demand and a crisis that need to be solved, then everyone learns how to communicate very quickly. Right. So you start, is it important or not to solve the problem with the emissions? Well, if it is, you look at steel alone, it represents 10% of all the CO2 emissions. So then it's a big chunk of the puzzle. How do we do? And so we don't need to prove demand. Demand is there. So therefore, it eases the path of implementing a timetable and communicating what needs to be done.
So and humanity, both with the COVID vaccine, and we're seeing some LNG construction projects in Germany, where when there's a crisis, we somehow make things happen that normally people go, no, that's not possible. Oz, what can we learn in the absence of crisis, because the oil industry does this well without a crisis? What can we learn? What can we learn from you guys?
I'd like to share a few examples just quickly. I don't know. I have a more optimistic view about the mining industry, because both industries have also borrowed technologies from the outside, from the medical community, CT scanning, NMR, technology, and it's being implemented as standard operating procedure. The problem is when technology is implemented, it's forgotten that it was new at one time and it was put into practice. Today, I'll give you one example of technology we're developing is new cutters that you don't have to change throughout from surface to reaching total depth.
Okay.
They're so durable. So that saves a lot of time. And going from here to the point of implementation, deployment, and even commercialization, it's still a process and it takes some time. And it is transferable across industries. But I think the scale, the economy of scale in the oil industry is a lot stronger. And I'm no economist here, but I'm just saying that the implementation and the ability for service companies to bring technologies to a commercial entity that is used widely is a lot better. It has to be, just by virtue, in the absence of crisis, of course.
Yeah, absolutely, yeah.
So there's a lot of innovation coming in, and it's going into practice and deployment across the whole industry. And my point is, how can you, as a mining industry, accelerate the transfer of some of these technologies across? And it goes both ways.
Yeah. No, I agree, and I think that acceleration's important, collaboration's important, and I think there needs to be more investment because the mining industry invests 0.5% of revenue on innovation compared to the oil industry 4.5%. So you get what you pay for a lot of the time. So that, and we've heard a lot, we've got to increase the rate of that investment, we've got to accelerate the rate of adoption too, because we're not in a crisis mode quite yet, but we're getting there pretty quickly. So I've been given the 5-minute warning, which is now 4-minute warning. So what I want to ask each one of you, and I'm starting it right at the far end here, one takeaway for the audience here that you would like in 30 seconds from your technology. This is one thing I would like you to take away with you and do. So
Pavit, the takeaway for me always is that any process which you really want to get into, just don't limit yourself as to what's happening. Look at what is really the possible options. Consult with various people, various experts and things like that. It is because the knowledge is really very, very, very wide around, and then kind of come to the right conclusions which are there. This is what I have seen. And such forums really kind of create a possibility of achieving that.
Thank you.
That's what it was.
No, that's excellent. Michael.
I again address your question from point of view of exploration and geophysical exploration.
Yes.
But also applied both to mining and to oil and gas industry. I think the key is in the integration of different geophysical techniques. You have very well developed standalone seismic methods, potential field methods, well logging, but in order to evaluate mineral resources and oil and gas reserves, it's better to integrate all data together. And the key is how you integrate it, do it smart, use AI for better integration. I think this is the main development for future.
No, thank you, Michael. Oz,
last remark is that technology has to sit on two layers that are carrying it. It's the foundation of fundamental expertise and on top of efficient workflows.
Yeah.
Then technology comes in and it makes a huge difference. Without that, it may not work.
Exactly. Thank you. Yeah, Jim.
Before mid-century, mining has to improve its effectiveness by an order of magnitude and reduce its cost, energy, and environmental impact by an order of magnitude.
And we're going to make that
very good. So, milk doesn't come from the refrigerator. So, mining and mineral processing is a must.
Yes.
And it's very refreshing to see that the kingdom is really with a wonderful plan for the future of mining here.
Yeah.
So it's very necessary. It can be done the right way.
Yeah, no, fantastic. And I think, we all go to a lot of mining conferences, and I think the level of energy, excitement, and strategic thinking at FMF is kind of a couple of notches up from the more traditional one. I think really interesting to me to wrap up, guys, this has been awesome. We can just keep going. We talk about technology, but the human element's really important. We've talked about communication, collaboration, mindset. I think it's really important, and often is forgotten in technology because you've got to get those things right. I think another one is this kind of systems approach and integration. If you just target little things, you sometimes sub-optimize the system. And Jim, you're talking about, with the swarm robot doing everything and just ultimately, I think we have to just extract the mineral. You know, bringing up, I mean, it's really ridiculous to bring up a ton of dirt, crush it, transport it, crush it just to get 0.5% and less of copper out of it. And when you scale that to 40, 50 million tons of copper it's needed, I mean, that's just the, I mean, it's incomprehensible.
Environmentally criminal.
It's criminal, yeah. And right now, we actually don't have a way to do it differently. So, and I think that's urgent. So, along with steel, etc. So, guys, this has been awesome. Thank you very much. Please join me in thanking our really tremendous panel. Thank you.
Wonderful.
Well, thank you very much, Peter, and the different panelists for this very interesting conversation. I do appreciate your time and your knowledge. Thank you. Please. I will have the pleasure to moderate the last panel, which is dedicated specifically to the development of the business ecosystem and the technology ecosystem that will allow to have a sustainable mining sector development in Saudi Arabia. But before I do this, I'd like to try to piece the different, part of the piece of the puzzle together to try to give like a larger picture of what we've been trying to achieve during this session. This has nothing to do with the fact that we're running low on microphone. I've been told to actually gain 5 minutes. But in any case, what we try to explain here, and if you're, yes, gentlemen, thank you very much. What we tried to achieve here was to try to give you a comprehensive view of the needs in terms of technology here in Saudi Arabia to be able to turn the country into one of the key leading mining hubs in the globe. The potential of Saudi Arabia is huge. From the existence of resources, the capacity of developing industrial development in the country, transforming minerals into actual batteries for battery metals, also transforming through smelters a series of the resources. But to be able to do this, we need to have the capacity to implement the right technology. The first panel has made the point of the fact that technology can actually solve many of those issues. Not only the issues in Saudi Arabia, but the issues of the mining sector itself. Whether we're looking at license to operate of some of the projects, whether we're looking at the attractability of the attractiveness of the sector for the young and the diverse workforce in different countries, technology is the key to everything here. After that, we actually look at 10 different key technologies, whether on geochemistry, geophysics, the use of drones, the actual circular economy around mining, to be able to show you the kind of progress that has happened in the sector and the capacity for Saudi Arabia, because of political will, because of technological capacity, to really make this country jumpstart from a country where you have a limited number of mining projects today to a country that will be the forefront of the future of mining, implementing those different technologies. Then we actually looked at turning those large concepts into something more practical with the latest panel here. What we will do now with the different panelists here is to actually look at more how to attract and how to build the ecosystem that will make this implementation of technology sustainable. How to make sure that you have the right kind of data that will be, nourishing the knowledge of the mineral sector and making sure that we actually build the right technology. How do we actually build the capacity through academic hubs, for example? How do we actually work through the training of the workforce, using those technologies to make the Saudi mining sector a sector that will be the key to the economic diversification of the kingdom itself? Now, a lot of us actually go to different conferences around the world, and we talk about the mining sector in countries such as Peru, Chile, Argentina, South Africa, Australia, which is a very established mining sector, and sometimes you need to economically diversify away from that sector. Here's the other way around. Here you have a country with a very large oil and energy sector where the mining sector itself might be the key to the economic diversification of the country, where the mining sector might actually offer the capacity to unleash new technologies, new ways of operating businesses, new diverse workforce. And this is actually what we're actually going to be covering with my three panelists, which now are all mic'd up, and which I'd like to actually welcome here on the stage. The first one is Marcio Pelizon, who's Business Development Manager at Al Atham Mining Company. The second panelist is Dr. Philip Schmidt-Tome from the Geological Survey of Finland, in charge of international operations. And finally, Jane Smith, Chief Executive Officer of DRA. Please join me on stage.
So gentlemen, thank you very much for joining us. We have a huge task, which is actually trying to piece all this together and make the last half an hour very interesting before maybe we actually will partake in a nice dinner all together. So maybe my first question here, I believe is for Philip, if I'm not wrong. We'll be looking at specifically the question of data itself. So if we want to have the right technology implemented here in Saudi Arabia, if you want to have the correct understanding of what will be needed in the sector, if we want to have the right geological survey and others, we need to have the right data collected. And I think, it'd be very interesting to see what you can bring here to the conversation in terms of how to have a better knowledge that can be offered in the mining sector, of having, reliability of data archiving into the geological survey here in Saudi Arabia, to which you actually contributed from the collaboration with Finland and Saudi Arabia. Please take it away from here.
Yeah, thank you very much. We've been discussing this just with a lot of other colleagues. If you look at the results of the Fraser Institute that are regularly published, and particularly on countries that are able to attract international investment, Finland has been sticking out as the number one country for the last 5 or 6, not even 10 years. So the issue is that if you have geological data, first of all, you have to, of course, ensure that you have very good geological data. You have to maintain the geological data, and as you have already mentioned, you have to archive it. But the main secret is then also not just to have the data and to have a nice database, but how are you actually going to attract investment into the mining sector? So the data should be for free. And this is what, the service that we provide in Finland is that you can virtually start your exploration from your desktop at home. You don't even have to travel to the country. And it's all for free. Only if you want then very specific, very detailed data sets, there's a certain cost attached to it, which is basically because then we have to go and give you all the specific data. But then the other issues I've mentioned already, the data quality. So it's not enough to just put some whatever geological data in there. So you need, I wouldn't promote a geological survey. It could be whatever institution that has the expertise to oversee and to ensure that the data is of good quality, and that can also, in the case that investors come, guide the mining companies that what does this geological data actually mean? And where would you then have to actually target your exploration? You would need very much geophysics for that. And that will then generate a trust, of course, in the mining sector and in the data, and that will then lead to an influx, at least that's what we see in Finland, of investment into exploration. The last thing is this data archiving, and this is why I promote in a certain way that is it worthwhile to give this to a private company, or would you rather do that on a public space, so that you have the assurance that this data will definitely be managed over a very, very long time horizon. Thank you.
No, perfect. To just build on this, and maybe turning to you, Marzo.
Yeah.
We talk about generating transparent data, but then we have to be able to use it and use it locally.
Absolutely.
One of the things that the Kingdom has done very well is to rely on international collaborations, on best practices internationally to start building and jumpstarting the sector. But then you need to make sure that you actually have the right manpower, the right institutions, academic institutions here to be able to build sustainably the sector itself. Could you actually maybe share with us some of your thoughts about how to build this technological, business, academic ecosystem to have strong and sustainable path forward here?
Absolutely. AGC, Alaita Mining Company, is a local company that is already carrying more than 200 Saudi employees, over the 800. And is able, with more than 60 geologists, and has been able in the years, under the leadership of our founders, Mr. Khaled Jedali, and the CEO, to build up the local content in terms of partnerships with institutions, with university, King Saud University between the others, and to enhance the local requirement. Local requirement nowadays is not, can be answered why needed. The answers may be easy because the Saudi Vision 2030 requires. But actually the Saudi Vision 2030, it has been ahead of times. because with the new world that all of us were living after the pandemic and the shortage of worldwide manpower that is skilled and unskilled even, that is in most of the key countries, it is an essential requirement nowadays. And therefore, a local qualified contractors with local qualified manpowers is essential. Nowadays, the difficulties would be, maybe this is the next point, is how to enhance the qualified local manpowers. Saudi Arabia beating the world champions, Argentina is the best examples that Saudi young, talented, can make any job in the world. Need to be motivated. I was in the panels, I was hearing a panels before, they was speaking about mining sectors, very willing to go, was very intelligent point, that they was willing to go to electrical cars to move stuffs. And the expert was saying, so why you need to move people? You need to go to remote works. So that's all the ways that need to be studied in order to let the Saudi to come inside of a mining sectors that is famous to be a very hard works. And so that is the ways how to cooperate again with institutions, with the government, but also with the miners, how to build up these activities.
And still on this idea of local skills and building the local workforce, and maybe turning to James. I mean, we're seeing here a very ambitious roadmap through the different, Vision 2030 and the desire to go from, first steps of the mining sector towards very quickly, very ambitious objectives in the mining sector. You've been working in several jurisdictions around the world. Could you maybe give us some examples of countries where, you've seen this same process of building local skills, of building local institutions, some key lessons learned from those, an example that could be blueprints for Saudi Arabia to continue the journey?
Yes, thanks. Look, I spent a bit of time in the main session today, and it was very exciting to hear all the plans, not on a global basis in terms of how much mining activity needs to happen. I mean, if you think about copper and nickel, cobalt, etc. But for us as a mining services industry, it is also makes us quite nervous, because if there's one major growth inhibitor for all of us, it's skills. We are in a skills crisis globally, whether we like it or not. This industry is in a skills crisis. It's translated into a huge, what we call a war for talent. So to get good people, to go to the right places, to take on these jobs is costing us more every day. And our biggest, one of our biggest challenges is getting young people to enter this industry. It is not traditionally not the most attractive industry to join. So this is our challenge. And it's not a quick one, and it's not an easy one to fix. I would like to believe, listening to some of that previous session, that, we'll become autonomous one day and be able to send robots underground to pick out the bits of metal, as we were talking about. But let's be realistic. That is many years away. And if you just look at, we've been on journeys ourselves as a group in terms of trying to automate and digitize a bit more, but we're only at a phase now where we can maybe do some remote monitoring. We are not even close to proper automation, and I think we're many, many years away from that. So the skills crisis is on us. We have to solve it, and we have to get a bit creative about how we solve that, because it's not a simple one. And what makes it particularly difficult in a region like this, which is rapidly growing in a very short space of time, is it doesn't have that. In other jurisdictions, we've been lucky. We've had tens of or decades of skills base that's been developed, whereas here we have to build it very quickly. So we've got to be creative. So, in terms of what can we do, I think there's no way of getting around it. We have to invest, and I think there's 3 levels that we have to invest on. The first one, and always an important one, is the formal sector. So, universities, technical colleges. Getting the right skills into the industry, and we as industry players need to partner with those institutions, and we need to invest with them in graduate programs, work with them, and we're at fault in some way of not working closely enough with those institutions to they are great sources of innovation and knowledge and research. Working with them, putting money back into those programs to get the graduates out that we're looking for. So that's the first one, very important one, but on its own, I don't think it solves the problem, because the biggest gap that we see is the divide between a graduate coming out of a technical college or university and that person being practically ready to operate a plant or operate a mining operation. And let's be honest, I mean, when we talk about the skills crisis, it is not just at a very senior engineering type of level. We've got skills crisis going right through our organization. So, and I'll give you one example now. With everyone moving to underground mining, and particularly mechanized underground mining, we have a huge skills crisis in just finding operators of mechanized machines underground. And that's a global problem. So that the practical side of how do we take people that have the basic skills and get them to be practically ready, we need to go back to basics there. We need to, on-the-job training, reinvest in that. The training centers we used to have, we need to reinvest in those, and regions like Saudi Arabia need to build out those with us as mining service providers in terms of training centers for the future, getting those practical skills into the workforce. And yes, it takes time, but we've got to find ways to make that more rapid. The third part, which we've actually realized now, we've underinvested in for many years, is investing into your people that you have, the great people that you have, to keep them in the industry and give them a career path that can say, listen, you can get to where you want to be 20, 30, 40 years in the mining industry. It's a great place to be. It's moving forward. It's modern. It can give you anything in a career, because the worst thing that can happen to us is we create great graduates, we train them practically, and then we lose them to other industries. So we've had to rethink that and how we reinvest in keeping our people and giving them that career path, that mentoring, that coaching. It's invaluable and difficult to put a price on. And then my final thought on it is, in a crisis like this, you're not going to solve it with just doing the same things over and over again. You've got to get a bit innovative. So digital and technology is going to play a role here. It's not the silver bullet, I don't think, but we have to harness the technologies we can, whether that's remote learning, remote interactions between people, whatever the tools that we can bring to bear on the skills crisis, we've got to unlock those. And we have to be a bit innovative. And I think, let's be honest, in this industry, we've relied on experts with 20, 30, 40 years experience, but you cannot create those overnight. If you've got a 5-year problem, you're not going to create a 30-year expert. So how do you, and what we're playing around with now is, how do you take those old grey-haired experts, putting them with these young, dynamic, digitally kind of ready, digitally hungry people that are coming out of the graduate programs, and finding a winning partnership between those two skill sets that really cuts down your time. So I think a lot to think about, a lot to play with, but it's going to take investment and it's going to take innovation.
I find what you're saying very, very interesting, because you're making the point of the complexity and comprehensiveness of the question of inclusion of technology in a sector like mining. It's not only about shining new technologies and innovation, it's actually about being able to implement it with a variety of actors, variety of approach, whether it's with institutions such as academic institutions, but also training the workforce, making sure that you have a human resources policies to maintain those skills. And what we have in mining is a very complex and comprehensive sector that has the capacity to really move forward in the country, but also needs to actually work with a series of different actors. And maybe just turning to you, Philip, when we're looking at the different stakeholders at play here, the role of different authorities, whether it is on the licensing front, whether it is on the policy makings from the government, of the different actors that are involved into the mining sectors, companies, workers, and so on. How do you see the interplay of those different authorities and different stakeholders? And maybe specifically because Finland is known for its transparency and its rule of law, and it's a good ecosystem to sustainably develop a business. Where do you see the role of transparency in all those different methods and processes for the development of the sector?
Sure, thank you very much, Remy, for the question. First, I want to reflect to what James has said, because I remember when I was studying geosciences, which is of course quite some time ago now, there was a lot of unemployment among geologists and geoscientists. So a common joke was, what does a geology student say to a PhD geologist? And he would say, I'd have a Big Mac menu, please, because the geologists wouldn't find any other employment than in McDonald's. And this is completely different now. So we also have to think in these cycles. And what we've been seeing right now in Finland, if I remember the numbers correctly, is that we have a record applicants for studying geology. So more people than ever actually interested, because we've been also broadcasting this a lot, that mining is important and so forth. But of course, as you have said, it takes time until these people are actually educated, trained, and they have the necessary experience. And coming back to the robots you mentioned, well, somebody has to train your robots too. Right. Okay, you call it programming, but I mean, it is like training. It's not just put a robot in a mine and it will do the job by itself. So we do have a big problem there. But coming then to your question, how do you actually structure a mining sector? And this is something that is quite interesting, what's happening in Northern Europe. Finland and Sweden are virtually the only countries that do serious metal mining as two countries in Europe. And we are famous, as you've said, for very, very strict regulations. But on the other hand, we see a record inflow of investment into the exploration of mining. So why so? The point is, and that is the feedback we get, and of course the other authorities I talk to, is that we've got very, very strict regulations. But they're extremely trustworthy. So everybody knows exactly how long it will take and what you will have to do. In addition to that, there's a very strong interplay of authorities, how I call it. So you know exactly which institution is under which ministry, and how do these ministries play together. So in the end, and this is also important, is that the entire permitting process, the licensing process, is transparent. And it's absolutely transparent to everybody. So you know exactly how much time you need, you know exactly how much it costs, and you know that everybody's been played with by the same rules. Right? In addition to that, of course, you need infrastructure, which is also part of this interplay of authorities, like how do you actually reach the mining area, how do you then get the material in, the material out, and so forth, where do you have schools? I mean, all of these issues that is important. So there is an interplay, and you've been mentioning this also as well as you have. The industry has to cooperate with the research sector, and we promote this a lot, and we do it a lot, but then also we talk a lot to the ministries, and also the industry does. So the actors among themselves have to talk to each other, and I was very happy to also refer to the panel this morning that the environmental and social governance issues are rising more and more. Yep. Because only if we take ESG serious, and we all know what social media do, if we take these issues serious, then it will be the only possibility to reduce the resistance in mining. And the resistance in mining can only be functioning if those that are against mining know that, okay, we will now develop better regulations and we will implement them so that we don't have the adverse effects of mining on the environment and on the social communities around it.
No, very interesting, completely agree. And maybe if you want to react to this, Marzio, and look at also at the question of standardization. We've seen very interesting technology from large international companies or small international companies. We've seen best practices from around the world that could be applied here. How do we make it applied? How do we actually standardize it? How do we actually turn from international technology to actual local companies in Saudi Arabia that will become the leader of the future technology? Can you maybe just...
That's an interesting question also, because we are not facing only the issues how to transfer the international technology to the local technology, but also is the increase on the demand. The mining demands, the mining market is increasing by times and times every year, and the requirements are increasing. The examples, the practical examples, is international joint ventures to come to Saudi Arabia. We have, as a GCL item, we have two good examples with two world leaders, DTP Mining from France, that is a leader in the mining operations with more than 100 million tons operated every year worldwide. And we have, they are coming now in Saudi Arabia with established company with us. and with other company, international company from South Africa, Excalibur, for airborne surveys. It is essential, as James was saying, it is very correct, the digitalizations and automation is not coming from one day to the others. The good things of Saudi Arabia is that it's a young country, and the generations are very able to use and to accept the new technology, including the government.
Mm-hmm.
And it is essential to have cooperation between all the parties to bring this one together. It's not things that will come in one day, will take times, but international cooperations and dialogue of the industry with the government is the key ways.
Oh, very good. Maybe James, if you can, build on this idea of how to, integrate technology in Saudi Arabia, to turn Saudi Arabia in terms of, indigenously developing technology through, facilities, whether it's lab, whether it's, testing facilities and others. And how do you see the road forward on this, and from your experience specifically?
Yes. Look, in a market which is as busy as this is right now in mining, we as project developers, we often get asked the question, how can you bring this project online faster? That's the question. We cannot wait years and years and years. We've got to cut the development cycle down from 10 years to 3 or 4 years. How do we do that? And my first point I made is around the skills crisis. That's the first major bottleneck. The second major bottleneck that I see, or we see in our business, is there is a shortage of global capacity on what I would call a true research and development test work type of lab that you can count on to give you the information that you need to rapidly go into a design and a build of a new process. And if there was one thing I would think a region like this would look at developing is that center of excellence of, I'll speak to South Africa, where I grew up in the industry. We had an institution called Mintech, which made a massive contribution to our industry there. Why did they do that? They created talent. Probably some of the best metallurgical talent we ever had came out of Mintech. They did a lot of research and development. They came up with new technology. When you had a very complex problem, they would help you solve that. And at the end of the day, they gave you quality, reliable test work. And when I say test work, I'm not just talking assay, I'm talking everything through the whole process that you would need to do a proper design. What we're seeing now is there's very few institutions around the world that can deliver you that, and your waiting times are anything up to 6 months at some of them. So it's a major bottleneck for the industry. And I think for this region to unlock not only some of that skills crisis, some of the adding to the innovation and the research development, and then just giving us a much quicker pipeline in terms of quality test work to start a design on. That's an institution I would invest in immediately.
No, thank you. We went through a very complete afternoon, probably 3 or 4 panels, if I'm not wrong, 10 different individual presentations. We didn't have a lot of time to open for any questions, so I'm just looking around in case there's any question from the audience to make sure that people can participate. But if not, I'd like to ask you maybe for any concluding thoughts that would have a key idea that you would want people to go home or back to their country or develop here in Saudi Arabia with. And maybe Philip, if I can start with you, of one concluding ideas, summarize what we've learned today into the role of technology in the mining sector, or what you'd like to share with the audience.
Well, discussing with the people and reflecting on this, I think coming back to the education, what many people do not know, especially if we talk about resistance to mining, is if you can't fish it, grow it, or hunt it, you have to mine it. And most people that I talk to, me as a geoscientist, and then they say, but mines destroy everything. I say, how many mobile phones do you have at home? They say, why do you ask? I say, well, where do you guess that the minerals for your mobile phone come from? You've got a computer, you've got a TV, you've got whatever. So I think we have to also, from our side, educate the general public how important mining is. And I think there must be a general understanding, if we want to have now the energy transition, we need mining. Without mining, it's not going to work. Simple stop. And I think there's a big gap in information. And once we can solve this information, we will also solve, at the same time, the problem of skilled personnel, of skilled people, and we will then, of course, also get a better understanding how mining should be done, starting from data, but going over the interplay of authorities towards, hopefully, a more responsible mining, and then, as was mentioned in the former panel, a brighter future. Thank you.
Perfect. I don't see any hands for the moment, so maybe Marzio, if you can actually provide your concluding
Absolutely. I think that you are very right, Philip. Educations of the importance of the sustainable of mining is essential, and also is very essential to have long-term education plans, because skilled staff from any levels, not only the PhD, but also the skilled operator, skilled junior geologist, are essentials, and this is there is a gap, worldwide gap. This needs 10 times, need concentrations. The world is going to revolutions, to the green revolutions. The green revolution has a consequence that need mining, more minings, absolutely. And these more minings, for the responsibility that we have versus the next generations, is to be responsible minings in a sustainable way and safe way. Yep. Absolutely.
I'm looking for the last call for questions. No? So then, James, you have the incredible responsibility of
final thought. Look, I think it's obvious, you don't have to listen to many sessions from today to not see that there's a huge amount of opportunity in the sector right now, globally, and particularly in a region like this. The ultimate limiting factor, I would believe, is people. We can try and get away with it with technology and automation. I just don't think it will come quickly enough. It's not practical. If we can solve the skills crisis, then I think we can meet all our expectations. But that's going to take investment. It's going to take the coming together in partnerships between the institutions, the big mining houses, and us as a mining services community as well, to do our part. And if we all do that together, I think we can get there. But time is short, and we're going to have to do it quickly.
Oh, perfect. Thank you very much for this. And I'd like to ask you to join me to thank the different panelists for this complete panel.
Thank you to you, Rami, for your moderation. Really. Thank you. Very interesting indeed.
Now, as we finish this session, we have the right of a little photo before we do this, okay? Cheers, okay. Perfect, thank you very much. Now, thank you for this.
Thank you, Rami.
Pleasure. Pleasure. So just to, I've been asked to give a few concluding thoughts about, what we've tried to achieve here. I studied a little bit before this panel, but I'd like you to keep maybe 3 main ideas on the conversation that we had here. Actually, maybe 4. The first one is, please reach out. I mean, I've been very impressed by, talking to all the different panelists here or the presenters by their will to share their experience. You have another day tomorrow to go to their booth to understand better the technology, to understand maybe how things have been achieved in another country, to standardize it, to actually include it and have it as part of the development of the mining sector here. So just use this opportunity. There's an incredible capacity here in this conference to bring those best technology leaders, to bring those experience from other countries. So do take the initiative to go and talk to them on the different booth. Maybe on a couple ideas. First of all, on the integration of technology. The first one, as the 3 I had, the first one is that we see when we look at different countries around the world, a series of countries that have been stuck into the production or the mineral phase without being able to move away from resource curves or move away on the value chain of the mineral sector. What we have here in Saudi Arabia is really a will to have and integrate technology so that Saudi Arabia doesn't become just a mining country, but actually becomes a leader of mineral processing, of mineral transformation. Whether you look at companies such as EV Metals that is now getting installed next to Jeddah with battery metals and so on, by including technology, you're going to be able to have a country here that will be a leader of the entire chain of mining, not just the exploration, but also the transformation and the commercialization of minerals that are essential to the energy transition. The second idea that I wanted to mention in terms of the importance of technology into mining is the fact that the mining sector has been criticized on different fronts for potential impact on the environment, for its capacity to have diverse workforce, for its capacity to actually attract bright minds, and technology is probably the answer. Technology is the one leverage that will attract the young leaders of tomorrow, that will allow the sector to be much more sustainable, its capacity both in terms of impact on environment, impact on communities. There's a series of different platforms of communication for different communities that could be actually implemented here, and also for governance. We talked about transparency, for example, a key element that will allow Saudi Arabia to showcase its capacity to have transparent processes, transparent licensing through the mining sector. And maybe the last idea that I wanted you to keep in mind here is, as I said, international collaboration. It's about technology, yes, but it's also about people. There's very good technology out there, but there's also very good people that are ready to engage with different Saudi institutions, and that will allow, through that international collaboration, to have Saudi Arabia as a future leader of technology through the mining sector also. As I was mentioning, Saudi Arabia is probably the one country where the mining sector is the leverage towards economic diversification, as opposed to other countries where the mining sector is big and you're talking about economic diversification away from mining. And through this development of the mining sector, through the inclusion of technology, through the inclusion of the latest ESG framework, whether you're talking about towards sustainable mining, the Copper Mark or others, you might be able to have a real societal transformation and economic transformation in the way you do business through the mining sector. So technology is a key component to this. ESG is another one. I strongly invite you to join us at the Social Impact of Mining event that we're doing tomorrow, same kind of a format. But that's where you will see that by international collaboration, inclusion of technology, Saudi Arabia will be able to achieve its 2030 roadmap and its objective of both including a more and more diverse workforce and diversify its economy towards being a large player on the mining sector and mineral processing chains globally. Now, thank you very much for joining us. And as I said, if you have any questions, we're here to help, we're here to answer them, and we're here to collaborate. Thank you again.
you.